Hello, Katli. Hello, 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 hello. Is it grade 10? Grade 10s, grade 10, grade 10s. I haven't had a session with the grade 10s in a very long time. I'm sure they're probably thinking like, hey, this guy has abandoned us. Hello. Hello, Katli. When are you guys writing, by the way? Just let me know in the comment section. When are you guys writing? When are you writing your control test for the term? I wanted to just review some things from your guys' syllabus. I do believe that you guys are doing, or you will be writing a test, real number system, algebraic expressions. Hey, Opelong. Kekan, how are you doing? I wanted to check, are we doing, when are you guys writing your control test for the term? Do you guys know? Maybe you can let me know the province where you're from, the province that you actually are located, and when you guys will be writing your control test. Okay, so currently you're writing on the 17th of March. Are you guys done with the syllabus? And are you aware of what topics you guys will be covering for the test in your control test in your particular province? Because remember, I guess I'm just wanting to see if like we are all kind of sorted. Yeah, so obviously you guys need to be very much aware of the real number system, right? The real number system. What do you need help with, Caleb? So you guys need to be very much aware of the real number system, the real one. All right, and then you need to actually make sure that you know rational numbers and irrational numbers, obviously. And hopefully we got a very good understanding of what the difference is between them, eh? Oh, you wrote a class test on trigonometry. Nice. How was that? How was the geometry class test? But if you're saying you need help with everything, that's very broad, Caleb. That's very, very broad. Okay, Trig had some struggles there and there. Okay, all right. Okay, so very quickly, I actually what I decided to do was to actually take. There's a test that I posted up on the TikTok channel itself. And I just wanted to sort of like utilize it so that we can use it to to sort of like look at some things where it's concerned. I'm sure you guys know, you've seen this, haven't you? Yeah, I'm sure you have. So I want to look at this actually, because it starts off, and I just want to see if we are all on the same page where this is concerned. I'm just gonna use it. Okay, so I'm going to attend to everything else. We're just gonna have to be patient, very, very patient. But obviously our patience will yield something, right? Will yield something. Remember guys, I don't know how they will set the test in your respective provinces, right? But what I can tell you is that obviously you need to have a very good know-how of the work that you guys have covered this term, which is very important. All right. Okay, so let me just, okay, so basically I want us to look at these. All right, I know this is basically, I just thought, let me just put this down. Okay, you've been working on this question paper, that's good. Okay, now remember guys, for the scope for this term's test, remember that you guys are going to be covering pretty much everything that you guys have covered at your respective schools. So if you're in grade 10, which is basically like, yes, I'm going to be posting this on the YouTube channel. If you are in grade 10, just remember that you guys are gonna, obviously you need to make sure that you understand the real number system, the difference between a rational and irrational number. You must be able to, you must be able to identify rational and irrational numbers. You must be able to also convert terminating decimals, which are a type of rational number, terminating decimals and recurring decimals. You need to be able to convert those into fractions. Then also, like, there's things like being able to know between which two consecutive integers does a particular irrational number lie, okay? Between which two consecutive integers. They ask those questions, and those are all sort of like questions around the real number system. So you guys need to have a very good grasp of the real number system and those kinds of questions. Then there's algebraic expressions, okay? Algebraic expressions has everything to do with factorization, all types of factorization you need to know very well. You need to know the factorization very well. Then there's the multiplying out, like multiplying out a monomial by a binomial, a monomial by a trinomial, a binomial by a binomial, and a binomial by a trinomial, and all of those things. So those are things that you need to know very well. Then your addition, subtraction of fractions, multiplication and division of fractions, algebraic fractions. You need to know that very well as well. Then there's the whole host of section that you refer to as your exponents, exponential, simplification, that's for multiplication, division, then addition and subtraction. And then obviously then you have exponential equations, okay? Exponential equations is the whole shebang, like the whole shebang of exponential equations. Then you have your algebraic equations together with your inequalities that you need to know very well as well. And then after that you have your trigonometry, okay? So that's pretty much like the terms work that you guys need to know very well, and I'm guessing your test will cover those aspects, okay? So from real number system to algebraic expressions, everything under algebraic expressions, your equations, your inequalities, trigonometry. And in trigonometry, that's like everything in trigonometry. Being able to use the right angle triangle to be able to state in terms of sine, cos, and tan, like what the ratios are. Also, there's obviously like your special angles. There's your reciprocal ratios as well, your reciprocal ratios. Then also there is the trig equations as well, okay? And then there's those Pythagoras type questions where you have to sketch a particular right angle triangle in a specific quadrant. That is also all encompassed in that one specific section of the work in trigonometry. So all in all, that's that, okay? So guys, we're gonna go through this very quickly, these questions, because the first question in that question paper that I posted was saying you need to be able to identify rational or irrational number, okay? So you have the first question, you have the first number, which is the square root of 15, and all I want to check from you guys is, do we know square root of 15, is this a rational number or an irrational number? The square root of 15, okay? So first and foremost, this is a square root, guys, and then the number 15 is inside the square root. So is this rational or irrational? Do you still remember what a rational number is? A rational number is a number that can be written as a fraction, where the numerator and the denominator are basically integers, and where b cannot be 0. That is basically a rational number. Okay, can be written in the form a over b, where a, meaning the numerator, and the denominator are integers. Integers are positive and negative whole numbers, guys. Positive and negative whole numbers, they increase and decrease by 1. So you would be looking at, like, for instance, 1 over 2. Is this a rational fraction, a rational number? Yes, it is, because 1 is an integer, 2 is also an integer, and obviously the denominator is not 0. You know, negative 3 over 5, is this a rational number? Yes, it is, because in the numerator and the denominator we have integers, and though this is negative, at the end of the day, like I said, integers are positive and negative whole numbers. They increase and decrease by 1. Okay. When we're looking at decimals, there are 2 types of rational decimals. We have terminating decimals, right? These are like numbers, decimals that basically come to a stop. So for instance, 0.57, so we stop at the second decimal, so that means that is a terminating decimal. 0.8173, okay, so we stop at the 1, 2, 3, 4th decimal place, so that means that is also a terminating decimal. Numbers after the comma, they stop at some point, they don't continue forever, infinitely. All right, so that's terminating decimals. Then the other type of rational number that we get in decimals is recurring decimals. The word recur means to repeat. All right, and basically if we say 1.5, so for instance the 5, above the 5 you can see there's a dot. Okay, that dot stands for repeating. So what number after the comma is repeating? The number 5. So this would be like 1.555555555, but it goes on forever. This is what we call a repeating decimal, and we use this symbol, sort of like a dot on top of the number that's repeating. Or sometimes, guys, instead of a dot they use a line. So for instance 3.8, above the 3 and the 8 there's a line, it's horizontal, and basically this signifies that the 3 and the 8 they repeat. Okay, so this is what we call recurring decimals. Okay, 2 symbols that you need to know: the dot symbol, which indicates that that particular number that the dot is upon repeats, or a straight line that's horizontal that indicates that that number, the numbers that basically are under that line, it means that they repeat. Okay, so this would be like 1.3838383838, and so it goes. 361. This here also, look at this, 0.361. So this basically indicates that the pattern 361 repeats infinitely. Okay, so I hope you guys understand that under your rational numbers, yes, rational numbers are numbers that can be written as a fraction, of course. So they are represented as a fraction where the numerator and the denominator have to be integer numbers. So they have to be integer numbers, the numerator and the denominator, but the denominator can never be 0. And do you guys know why the denominator can never be 0 for a fraction? Can anyone tell me in the comment section? Why can't the denominator be 0, guys? What happens if we have a 0 denominator? What do we say about that number? If there's a 0 in the denominator, what do we say about that number? Anyone? The moment we have a 0 in the denominator, what can we say about that number, grade 10s? Anyone know? Okay, Blue Sky says no answer. But more specifically, guys, what do we say? Okay, thank you so much. Yes, undefined, guys. This is the important thing here. So if a number has a 0 denominator, we say that it is undefined. And that's very important. Please, guys. So that's why, for instance, we say 6 over 0 is not a rational number. Okay, so the condition is that a and b, yes, have to be integers. Okay, 6 and 0 are both integers, but the denominator can never be 0, because if it is 0, then this fraction is not a rational number, but we say it is undefined. Okay, so more specifically, guys, it's undefined. Even what the calculator says when it says maths error, it simply means that that fraction is undefined. Please, guys. So within our real number system family, we have rational numbers, and I've given you the definition. Rational numbers are numbers that can be written as a fraction when the numerator and the denominator are integers, but the denominator can never be 0. If you look at decimal numbers for these types of fractions, you can either see them as being terminating decimals. In other words, the number will, after the comma, will have there'll be a few numbers, either 2 numbers after the comma, 3 numbers after the comma, but they come to a stop at some point. Okay, then recurring decimals. These are decimal numbers where the number after the comma, you'll see a repetition in their numbers after the comma. Okay, either one number repeats, or it could be 2 numbers that repeat, or it could be 3 numbers that repeat, but they repeat infinitely. And this dot, the line that's horizontal, they all signify this repetition. Okay, that's rational numbers. Okay, irrational numbers, on the other hand, they cannot be written in this form. Okay, but rather irrational numbers, they are non-terminating and non-recurring. Okay, sorry guys, I'm just gonna come back. Okay, sorry about that. Just had to attend to something very quickly. So I was speaking now about irrational numbers. So irrational numbers, guys, are numbers that are they cannot be written in the form of a over b, where a and b are integers and where b cannot be 0. Rather, irrational numbers, they are non-terminating, meaning, in other words, you will never find that after the comma they stop. You know, they go on forever, but there is never a repetition as well. Okay, so they will not repeat, they will not stop, because the word terminate means to stop. So in other words, they do not stop at a certain point, they go on forever, and they don't repeat. So you'll never find that when you are going through the numbers after the comma that there's actually a repetition. No, there's no repetition of a single number or multiple numbers. Rather, you'll find that they are all over the show, the numbers, but it never stops. After the comma, the numbers never stop. So those are irrational numbers. Okay, so that is the distinction between the two. And in grade 10, that's what, in the first thing you ever learn at the beginning of the year in your grade 10 maths is to distinguish between rational and irrational numbers. And all of us grade 10s need to know that distinction very clearly. Like, we should not have any doubts about the difference between a rational and an irrational number. So let's come over here. I want you guys to help me out in the comment section and let me know the square root of 15. Is this a rational or an irrational number? The square root of 15. Hello, TTV Calvin. Good to see you. The square root of 15, is it a rational or an irrational number? The square root of 15. Okay, Dave says irrational. So does TTV. Okay, Masupa as well says the same thing. Alright, so we have 3 people in a row that have basically said that square root of 15 is irrational. And you guys are 100% correct. The square root of 15 is irrational. One other way that you can obviously confirm that it is that, look at first things first, this is the square root. Okay, so since it's a square root, the number, what you are expecting is that if it wasn't an irrational number, this would be a perfect square number. But 15 is not a perfect square number. Okay, imagine if this 15 was not 15, but it was the square root, let's say the square root of 9. Okay, so the square root of 15, yes, this one, it's irrational. Okay, and when you take the square root of 15, you put it in your calculator and you say, and you press that button SD in your scientific calculator, you will see the behavior of the numbers after the comma. That indeed, one, there is no stopping in the numbers and there's no repetition after the comma. Okay, so square root of 15 is irrational. Indeed, it is irrational. Okay, let's move on to number 2. 2,5, is this a rational or an irrational number? 2,5. 2,5, is it rational or irrational? Great tens. Okay, Mbali says rational. So does Dave. So does Masupa. Okay, so we have 3 in a row again. TTV, Calvin, and Gatley have also joined in, and they're saying it's rational. And yes, you guys are spot on. This is a rational number. Why do we say so? It's because 2,5 is a terminating decimal, and we did say that for decimal numbers, when we look at rational numbers, terminating decimals, after the comma, those numbers come to a stop. This one comes to a stop after the first decimal, so indeed it is a rational number. You guys are spot on. Let's look at number 3. Square root of 16, rational or irrational? Okay, you guys are all on top of your game there. Okay, Dave says rational. Masupa says as well. Umbali as well is saying rational. TTV is saying the same thing. All right. Okay, and indeed, guys, the square root of 16, you can take the square root of 16, put it in your calculator, you get an answer of 4. And obviously 4 is a rational number, no doubt. Why do we say 4 is a rational number? It's because 4 can be written as a fraction, 4 over 1. Okay, and this is an integer number at the top, this is an integer number at the bottom, so indeed 4 is a rational number. As well as this as well, 16 is a perfect square. Seeing as though the number inside the square root is a perfect square, since this is a square root, the perfect square number indicates that this is a rational number. Okay, because we do get the number 4 once we apply the square root to 16, which is a perfect square, and therefore this qualifies as a rational number. So guys, you guys are spot on. Okay, let's look at number 4. 2,3333333, and then there's a dot. What is that number? Rational or irrational? Okay, Mbali says rational. Dave says rational as well. Masupa says rational indeed as well. So does TTV, Kama Peters, and you guys are 100% spot on. This is definitely rational. And why do we say this is rational? It's because this 3 after the comma is repeating itself, and it seems like they put the dot there to indicate that that continues to be 333 all the way through, infinitely so that indeed means that this is a rational number. We could write this in short form and say 2,3 dot, or we could say 2,3 with a horizontal line above the 3. Okay, so after the comma, guys, a repetition. Remember, we said rational numbers, when you look at their decimals, when there's a repetition either of a single digit, or it may be 2 digits, or it may be 3 digits, or it may be 4 digits, or it may be 5 digits, when there's a repetition indefinitely, infinitely, guys, okay, the last number, okay, after the the last number, if it repeats, or there's a repetition of a family of numbers, infinitely so, guys, we say that that is a recurring decimal, and therefore it qualifies as a rational number. So that's what I'm saying. And we use the dot above a number sometimes to indicate the repetition of that specific number, or we use a horizontal straight line above the number to indicate the repetition of a number or a group of numbers. Okay, so hopefully that answers your question very well, TTGV Calvin. Okay, yes indeed. Okay, let's move on. We're moving on very swiftly. I wanted to ask this question: the square root of negative 25. Okay, this is me just asking a question on the side. What type of number is this? Can anyone comment in the comment section? And why do you say what you are saying? Okay, TTV Calvin says an unreal. What does the rest of the crew says? Violet says undefined. Fatso says unreal. Fanny says non-real. Gugusho says imaginary number. Okay. All right. I think we are speaking a language that is quite interesting. Okay. So I want to make something very clear for us as the grade 10 group that is in this call at this moment. Okay. So the square root of negative 25, if you put this into your calculator, you will get the following message, and that is maths error. I want to explain that this maths error, okay, means something completely different from when you put 6 over 0 and you get an answer that is also saying maths error, or at least you get that message from your calculator, maths error. So this one, a negative number under a even root, and I repeat, a negative number under a even root. Sorry guys, can you just hang on? Okay, sorry about that. So as I was explaining, guys, that a negative number under a square root, okay, your calculator gives you maths error when you put this negative number, which is under a square root. So a negative number under a even root, and this is an important thing, even, okay. Remember, square root, you know, we don't write the 2 there, but this is what square root actually means. Okay, there's supposed to be a 2 there, all right, but we don't write that 2 because we understand that even though the 2 is not there, we mean the square root. So which is why when you put a negative number under any even, so we call it a square root because it's actually a even root. If we had the 4th root, that would also be an even root. If we had the 6th root, that would also be a even root. So any negative number under a even root is actually referred to as a non-real number, or we call it imaginary number. Okay, non-real or imaginary, very important, non-real or imaginary. So this maths error means something completely different from this maths error. Okay, all right. So a negative number under a even root is what we refer to as a non-real or imaginary number. So those that said non-real or that said imaginary number are 100% spot on. So in the grade 10 context, Okay, we must always be able to distinguish. Okay, so non-real numbers do not fall under the real number system. In the real number system, we only have rational and irrational numbers, which are the main, you could say, the main divisions of the real number system. Okay, obviously there's other things we can talk about under the rational number system. Like under the rational number system, we have a whole host of other family of numbers, like your whole numbers, your natural numbers, your integers. Okay, they all fall under your rational numbers. Okay, but apart from this family, the real number system, there's an entirely different family of numbers which we refer to as the real number system. Okay, and all even root numbers that are negative, we call them non-real, or we say they are imaginary numbers. So this maths error means non-real or imaginary. Then there's another type of maths error that you get when you put a number divided by 0. This maths error does not mean non-real. It means undefined. Please, people, do not confuse these two. They are not the same. Division by 0, all right, means undefined, whereas a negative number under a even root means non-real. Okay, please do not confuse the two, because people tend to think that when you have negative, the square root of a negative number, they say undefined. No, please distinguish between the two. So a negative number under even root means non-real or imaginary, but division by 0, okay, means undefined. Okay, division by 0 means undefined, whereas a negative number under a even root means non-real. Okay, so that is the distinguishing feature between the two types of things that you get. So a negative number under an even root will always be non-real, whereas division by 0 is undefined. Even though in your calculator you get maths error for both, but they don't mean the same thing. They do not mean, okay, the same thing. So I need you guys to have that and really remember that, and don't ever forget that. Okay, it will help you out in many other situations. Okay, when you go to varsity, this will have a sweeter meaning. You'll get to understand a little bit more about real numbers, you know, under the another guys. Okay, so please let us understand this for the grade that we are in. Then when we go to grade 11, it will make much more sense to us. Okay, especially when they ask questions about for which values of x is something non-real, as opposed to for which values of x is something undefined. Because when they say for which value of x is something undefined, they are looking at the 0 denominator. Okay, and if they are saying for which values of x is something non-real, then obviously they are looking at something under a square root or a even root, and they are looking at what could make that particular thing negative under the square root. So that's something you need to be very clear about. Let's move on, guys. I think I've overstayed my welcome there explaining that thing. Okay, then this one is asking the question, between which two consecutive integers, okay, does the square root of 10 lie? Between which two consecutive integers does the square root of 10 lie? I repeat, between which two consecutive? The word consecutive means a number that follows another one. Okay, consecutive is one after the other. That's what the word means. Integers, obviously these are positive and negative whole numbers. So basically we know that our whole numbers, they start at 0, they go up by 1. 0, 1, 2, 3, 4, 5. And then you have the negative numbers before 0, which is -1, -2, -3, sort of like going into the direction of negative infinity. So they are asking us, between which two consecutive integers does the square root of 10 lie? So for questions like this, guys, it's very simple. What we do, we just write down the square root of 10, no problem. And all we need to find is we need to find two perfect squares. Do we all know what a perfect square is? Okay, a perfect square number, guys, is like, for instance, the number 1. Okay, the number 1 is a perfect square. Why? Because there's a number that you can multiply by itself to get 1. For instance, 1 times 1 gives us 1. So 1 is a perfect square. Can you think of the next perfect square number after 1? 2 times 2 gives us 4. So 4 is also a perfect square number. Can you think of another perfect square number? 3 times 3, obviously, that is 9. So these are all, you know, your favorite chocolate. Your favorite chocolate. The PS. No, I'm just kidding, guys. Not your favorite chocolate. I know some of you don't like this chocolate. But maybe for Valentine's you love the chocolate, you know, because it has a message. But that's besides the point. So PS, perfect square. Okay, just a totally different meaning. So 1, 4, 9, these are perfect square numbers. All right. So what we need to do is we need to look at 10. And I need to ask myself the question, before the number 10, what is a perfect square number that I know that is before the number 10? So if you look at the number 10, what perfect square number exists immediately before 10? So if you look at this family of numbers, all right, before 10, a perfect square number that you know that lies before 10 is 9. Thank you very much, Dave. You are 100% spot on. Then we can go on further. What is the perfect square number that you know lies after 10? Okay, so obviously 1, 4, 9. Can you think of the next perfect square number after 9? Okay, obviously that will be 16. Perfect square number that lies after 10, guys. 11 is not a perfect square number, so we dare not put 11. 12 is not a perfect square number, dare not put 12. 13 is not a perfect square number, no. 14, no. 15, definitely not. 16, TTV, 100% spot on. 16, all right. Now, seeing as though the 10 is under a square root, we are going to do the same favor to the 9 and to the 16 that we have placed. The 9 that we have placed before the 10, the 16 that we have placed, the 16 that we have placed after the 10. So because it was square root of 10, right? Okay, how to see a perfect square number? So like I said, a perfect square number is a number that is formed by a natural number, a particular natural number multiplied by itself. Remember, natural numbers are numbers that start at 1. They increase by 1 all the way to infinity. So for instance, 1. If you multiply 1 by itself, you get the number 1. So number 1 is a perfect square number. The next natural number after 1 is 2. If you multiply 2 by itself, you get 4. So 4 is another perfect square number. The next number after 2, which is a natural number, is 3. If you multiply 3 by itself, you get 9. So 9 is a perfect square number. That's how we see perfect square numbers. Okay, these are numbers that are formed by multiplying a particular natural number by itself. 16 is a perfect square number. Why? Because we take the next natural number after 3, which is 4. If you multiply by itself, you get 16. I'm sure you can think of the next perfect square number after 16. You take the next natural number, which is 5. You multiply by itself, you get 25. So 25 is also a perfect square number. By the time you get to grade 9, you're supposed to know all the perfect square numbers from basically your multiplication of all natural numbers by itself from 1 up until 10. Okay, so that's why, for instance, the question asked, between which two consecutive integers does the square root of 10 lie? So you want to find, first and foremost, need to write down the square root of 10. This is actually a irrational number, funny enough. Okay, so square root of 10 is an irrational number, but the numbers you write before and after are both rational numbers. This is also going to be a rational number. You choose a perfect square before 10, which is 9. You put a square root over it. You choose a perfect square immediately after 10, which is 16. You put a square root in it. What is the square root of 9? It's 3. What is the square root of 16? it's 4. So you can conclude, therefore, the square root of 10 lies between what? 3 and 4. Okay, so that's how you answer those questions, guys. There's nothing much to it. Okay, like I said, they will always ask between which two consecutive integers. So 3 and 4 are consecutive numbers. 3 is followed by 4. 4 comes before 3, right? So these are consecutive integers. They follow one after the other. And indeed, they do lie between what? The square root of 10. Okay, so I hope that was clear and you guys kind of see, how to go about navigating that kind of question. Okay, okay, I don't know if there's any questions about that, but you see also these inequality signs that we use there. They all face this direction, please, guys. Okay, this was a positive number, so that's why we had the square root of 9 first, followed by the square root of 16, because with positive numbers, obviously the progression is from smallest to biggest in this fashion. I'm just trying to think if they had a question like this. For instance, they asked you find between which two integers, consecutive integers, does negative square root of 10 lie. And of course, guys, different situation with this one is that obviously the square root of 10 is a negative number. Okay, so then of course you are going to first say the number, okay, that is negative. Okay, so first and foremost it would be 16 this side, it would be 9 this side, but then of course your square root, you'd put a negative on this outside, negative on this side. Okay, and why is it this time round that you put the square root of 16 this side and the square root of 9 this side, then the negative sign on the outside? Kalogo, remember, guys, negative 4. Okay, sorry, let's put negative 10. This is progressive in this way, guys, as you would understand. Negative 4 is smaller, okay, than negative 3. Okay, negative 3 is bigger than negative 4. So that is why obviously you would start with the negative of square root 16, followed by the negative of negative square root of 9, which is very, very important, because they were asking you between which two integers does the square root of 10 that is negative, where does that lie? Okay, so this is something, guys, that you should all be comfortable with, very, very much so. Okay, and this is just me passing by, obviously, just that you guys need to know this very well. You need to know how to distinguish between a rational and an irrational number. You need to be able to also answer questions related to between which two consecutive integers does a particular irrational number lie. And then let's look at this last question. We are being asked to take 0.1 and write it as a rational fraction. 0.1, okay, repeated decimal. How do we write 0.1 repeated decimal as a rational fraction? And remember, okay, we have to write down showing our steps. We can't just use the calculator here. We need to actually show the steps, okay, because the question has marks. It's not a question that you can simply just answer by using the calculator. Okay, this question here is a good 3-mark question. So they ask you to basically convert 0.1 into a fraction. Okay, so if you simply go ahead and you just use your calculator, you may not be awarded all the marks. But if you are able to show your answer, then it will well be good for you. Okay, so you let x, first and foremost, very true Landiwe, we let x be equal to 0.1111. Okay, and we know that this 111 goes on indefinitely, and we say that is our equation 1. Okay, now the whole point is to set up two equations here, which we will eventually subtract. so that we can be able to represent our value of x as a rational fraction. Okay, because remember, we are letting x be equal to this, so we want to find the value of x as a rational fraction. So we then do this. We multiply x by 10 to set up a second equation. Remember, if we multiply x by 10, this simply means that we move the decimal one place to the right. So our new number will be 1,11111. We know that there's a repetition of that, so we'll say that is our second equation. The whole goal and objective of doing this is to be able to set up at the end two equations where after the comma the numbers are the same. Because if we can set up two equations where after the comma the numbers are the same, we will be able to subtract the one equation from the other and then be able to set up those two equations. So I'm going to do this example because it was a example in the test question that I just showed you. Okay, so for this particular question, we just need to set up the two equations. We first let x, which is the original and numerical recurring decimal, not comma 11111, and we put the dot 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 to indicate that that goes on forever. Then we take that decimal, we multiply the left hand side, which is x, by 10. But you know, most for equations, what we do on the left, we must do where? On the right. So if we multiply this side by 10, what does that mean? We are simply moving the comma one place to the right. So our new number here will be 1,111, the repetition, and that will be our second equation. Now, what do we observe about these two equations, especially the numbers after the equal sign? This number has comma 1111, and after this comma, this number also has 1111. So there's a repetition, and the numbers after the comma for both equations are the same. Perfect scenario. So I can clearly say now equation 2 minus equation 1. In other words, the big equation minus the small equation. So what I'm going to do is I'm going to say 10x is equal to 1,1111, which is my equation 2. And I'm going to subtract equation 1 from it, which is 0,1111. Okay. Now what is 10x minus x? That gives me a 9x. And then this side, 1 minus 0 is 1. What happens to all these ones? 1 minus 1, 0. 1 minus 1, 0. 1 minus 1, 0. That was the goal and the objective, guys. At the end of the day, I wanted to basically have on my right side a integer value. Then I can solve for x by dividing both sides by 9, and then that leaves me with x is equal to 1 over 9. There it is. There it is. The 0,1 with a recurring decimal can actually be written as 1 over 9. I've showed how that came about, and that is the objective and the intention of basically these types of questions. Okay, all right. Let me do one more type of this question so that you guys can probably just appreciate this phenomena. Okay, let's say we were given 1,523 and they said to us, write 1,523 as a rational fraction. So what we would do is we would do the same thing. We would let x be equal to 1,523, 523, 523. We can see the repetition, guys, that 523 is repeating after the comma, and it does so infinitely so. So we let x be equal to that. Then we are going to have a second equation, and we are going to strategically do the following. What would move the comma in such a way that I would eventually find myself having a second number where this 523 is basically available after the comma? Look, If I move the comma once, it means I'm going to have 15,23. That's not going to be the same. If I move the comma 2 times, I'm going to have 152,3. But after the comma, I'm going to have 352, which is not going to be the same with my original. If I move the comma 1, 2, 3 times, then I'm definitely going to have a repetition that is going to be the same after the comma, which is going to be 523, 523. So I need to move the comma how many times? 1, 2, 3. So what does that mean? I have to times by 1,000. So if I times x by 1,000, what happens? I move 1, 2, 3. What is the number that I have? 1, 5, 2, 3, comma 5, 2, 3, 5, 2, 3, 5, 2, 3. That's my equation 2. 1, 5, 2, 3, comma 5, 2, 3. So after the comma, you see after the comma for the first equation, I have 5, 2, 3. After the comma for the second equation, I also have 5, 2, 3. This is the goal, guys. It's trying to ensure that after the comma, the numbers are the same, so that when I subtract the two equations, on the right, I have an integer digit. That is the goal, okay? So I first check which one would be the appropriate power of 10, okay? That would be, I would be able to multiply by. So here it is. We know equation 2 is going to obviously subtract with equation 1. We take the 1000x equal to 1523, 523, 523. We know that repetition happens forever. Equation 2. Then we have equation 1, x is equal to 1, 523, 523. We know that repeats as well. We say that's equation 1. Then what's 1000x minus x? That gives us 999x. And then what's 1523 minus 1? That gives us 1522. And obviously this 523 all will give me 0. So that's what I wanted. I wanted to have a single integer value. Then I can divide both sides by 999x. No, not 999x, by 999, because remember, we divide by the coefficient of x, not the entire thing. We divide by the coefficient, which is 999, and then we get x is equal to 1522, 999. Then you just check with your calculator, because sometimes this can actually simplify further. And I just wanted to check from you guys, when you put 1522 over 999, do you get a further simplified fraction? Right, I will wait for the response in the comment section. If I do, then I'm going to write that simplified form. If not, I'm going to leave it like this. Okay, so no, I don't. So that means this is my answer. Okay, guys, I hope you guys get the art of actually showing, without using a calculator, showing step by step how you are able to convert a recurring decimal to a rational fraction. Okay. When it's a recurring decimal, these are the steps. But when it's not a recurring decimal and maybe it's a terminating decimal, like for instance 0.5, guys, this one you did in earlier grades, you should be able to see this one. You move the comma once, you get 5, but that's 5 over 10, okay? And then 5 over 10 can be written as half. So there's nothing much to this one. If it's a terminating decimal, guys, really and truly, there shouldn't be any difficulty at all. Terminating decimal, converting it to a rational fraction, straightforward. It's the recurring decimal that is needful of your attention, and just making sure that you are able to be spot on in your execution of that. Okay, right, any questions from anyone? Okay, so please guys, let's know how to do this, and let's flow very nicely in doing these types of questions as well, so that we can be able to get those marks for real numbers. Okay, limited marks, not too many marks from real numbers, but we must know how to do it. Okay, want me to do one more? I'll be happy to do one more. Okay, and remember, in my YouTube channel I have an entire section of like where I did this. I did a whole session on this thing where I explained it fully and completely. So you are more than welcome to also check that one out. It's very important. I'm gonna do this one. So here we are 1,2, but look at this out, only 3 repeats after the number 2. Okay, this is also a recurring decimal. I remember we are talking about this, guys. Okay, not remember 523 is a recurring decimal. This line above the 523 means the 523 repeats. So remember, that's a different. If the question was 1,523, if they said convert 1,523, this is a terminating decimal. Yes, this would be equal to 1523 over 1,000. Yes, it would be this one. Okay, but now I'm asking you 1,523. Remember, the straight line above, the horizontal straight line above the 523 means the 523 does what? It repeats. So this is 1,523, 523, 523. You need to actually show step by step. You let x be equal to that, then obviously you set up a second equation so that you can be able to subtract and then eventually get your answer. Okay, so grade 10s, that's very important to note. That's how we do it. Let's look at this one. 1,23, the 3 repeats, so this one is also a recurring decimal. So with recurring decimals, we have to first let x be equal to 1,2. Who's repeating? 3, 3, 3, 3, 3. Okay, we let x be that, indeed. All right. Okay, then the next thing we do. Now, please take note of something here. The repetition here, or let me say, after this comma, you have 2, 3, 3, 3, 3. Now, if you multiply by 10, you're going to have 3, 3 repeat. All right. In other words, there's no second equation that you could set up where you are going to have 2, 3 in the mix after the comma. This is the only equation that has 2, 3 after the comma. And as such, what we are going to do is we are going to set up 2 additional equations. And there's a reason why we do that, because remember, we want the 2 equations that will be having the same numbers after the comma. So what we are going to do, we are going to times the left hand side by 10. When we do that, remember what happens? We move the comma 1 place to the right, so that is equal to 12, 3, 3, 3, 3. That's our equation 2. Then we are going to set up another equation. We are going to call that equation 3. And we are going to multiply the original by 100. When we do that, we are moving the comma how many times? 1, 2 times. So that gives us what? 1, 2, 3, 3, 3, 3, 3, 3. Now, I'm sure you guys can see, all right, that it is by setting up these 2 additional equations that I now have 2 equations which I can go ahead and work with. Otherwise, the original one, I cannot work with it at all, guys. I cannot work with the original equation at all, besides just using it to basically set up the 2 equations that I could be able to work with. Okay, so I multiplied first and foremost this equation left and right by 10. So if I multiply x by 10, what I do on the left, I do on the right. It means I move the comma once to the right. So I have 12, 3, 3, 3, 3, 3. If I multiply this original equation again by 100 this time round, not by 10, then I get to move the comma here how many times? 1, 2 times. That gives me 1, 2, 3, 3, 3, 3, 3, 3. Now you can see that I now have numbers that are the same after the comma, which is what I want. So I'm going to take equation 3 this time and subtract equation 2. Okay, Maybe someone here is like thinking, so what if I multiplied again this x by 1,000 and had another equation which is 333, that would be okay. And what if, sir, I decided to take equation 4 and subtract equation 2? That would be fine. You'd still get the answer, all right? As long as you are able to set up the two equations that basically have the same things after the comma. Well, that's the beauty of it all. You can take any two equations as long as after the comma, those two equations that you have set up have the same numbers immediately after the comma. Because what do you want at the end of the day? When you subtract, you want all the numbers after the comma to disappear and for you to be left with what on the right? An integer. Okay, so now we're going to take equation 3 minus equation 2, so that means 100x. We're going to have a 10x here. 100x is equal to 123,33333. We know that repetition is for equation 3. Then 10x, remember this one had 12,3333, and that was equation 2. So when you subtract, what's 100x minus 10x? That gives us a 90x. What about 123 minus 12? What do we get? 123 minus 12, that gives us a 111, right? Okay. Yeah, and then we divide both sides by what? By 90. And then x is equal to what, guys? Is that the final answer? 111 over 90? Or is there a simplification of this answer? Can we simplify this further, or is this actually the final answer? Have I lost you guys? Is that why you're so quiet? You must speak up if you guys are lost, eh? If there's something that you are not understanding, please speak up. Thank you, Masupa. So that's 37 over 30. That's the simplified answer. And at the end of the day, that's what we want. We want the answer to be as simplified as humanly possible. Okay. Yeah. So guys, the whole objective. So imagine, let's say I had decided to multiply. Yeah, we simplify it further, please. This would be the mark, your final mark. You will only have it if the answer is simplified further. If you leave it like this, it's not good, guys. You need to leave it in its simplified state. The last mark for this question will always be made available for at your last answer. So you simplify it further. Yes, just quickly use your calculator. Using this thing of saying without using a calculator does not mean you don't use your calculator at all. It just means you need to show your steps of how you were able to get to the final answer. That's what without using a calculator actually means in mathematics. It means show your steps. We wouldn't want to just take the statement here and just put in our calculator and just write down the answer. No, that is not what they want. They want you to show your steps of how you were able to get to 37 over 30. And I'm sure when you put 37 over 30 in your calculator and you press SD, you guys do see that, oh, it does actually give me the 1,2 the repetition of the 3. So this actually makes sense now. You can check your answer, and not just simply leave it hanging like that. Okay. Yes, Masupa. You see now, you are making connections. All right. Okay, can I move on, guys? I'm sure, hopefully you've seen enough. I will be uploading this on my YouTube channel. The link is in my bio. I even just uploaded also like a video sort of explaining, because I have the YouTube channel, the playlist for the lessons that I've done with all the videos that I've done, the live videos is on there. You can rewatch any lesson at your own time. So I'll be uploading this after I'm done. If you've missed something, you can always go watch it at your own pace and really get a grasp of what I was saying if you have missed it completely. let's move on. Now we enter the world of factorization. Okay, yeah, so we have officially left the realm of numbers, the world of numbers, real numbers, non-real numbers, rational real number system with your rational and irrational numbers, and your non-real numbers, your imaginary numbers. So we've looked at that. Now we can enter into the world of factorization. Remember, we had 3 questions that were actually listed in that question paper. So let's look at those 3 questions, and hopefully we can see what we need to see. X cubed minus 8. So I'm hoping you guys know all the different types of factorization. We know we have highest common factor, we have dots. You guys need to know the factorizations, all of them, very well. We have trinomial, all right, trinomial, whether the constant term is positive or negative, we have that trinomial factorization. We have our advanced trinomial, where you have the coefficient of a that is greater than 1, or it could be less than 1. All right, and then we have cubic factorization as well. We have grouping factorization, and grouping factorization is coupled with common bracket, where we have a common bracket and we take out a common bracket. So highest common factor, difference of 2 squares, trinomial factorization, advanced trinomial, cubic factorization, and grouping factorization. You guys need to be hot in all 1, 2, 3, 4, 5, 6, all 6 hot spots of factorization need to be very well known by you. Okay, and if you know them very well, you guys will be killing the test. X cubed minus 8. This is cubic. Okay, and this is one example where there's a difference of 2 cubes. Remember, when we have cubic factorization, if there is no highest common factor that is not 1, then obviously we know that we open 2 brackets, because here the highest common factor is 1, and we know that there's a 1 that is there. We cannot see it, but it does exist. Then we just put our signs there. We know that there's going to be a minus sign, there's going to be a plus sign, and there's going to be a minus sign. That's what I can tell you. The minus sign for your binomial bracket, a plus and a minus sign for your trinomial bracket. Okay, then all we do, because we know the highest common factor is just 1, we take the cube root of x cubed, guys. Grade 10, we take the cube root of x cubed. What's the cube root of x cubed? It's x. Then we take the cube root of 8. The cube root of 8 is 2. We populate our first term and second term of the bracket by finding the cube root of x cubed, it's x, the cube root of 8, which is 2. This minus sign, it stays as a minus sign for your first bracket. Then what do we do to get the terms of our first and last term in the bracket? For our first term, we are going to square the first term. Yes. Okay, sorry guys, sorry. You are very right. Sunflower, you brought some sunshine into my life. You brought some sunshine into my life. Sunflower fixed me, and for Sunflower, I'm so proud of her, so much. So proud of you, Sunflower. You fixed. Okay. Yes, Sunflower is 100% spot on. The brackets, it's minus, plus, okay, for our signs. Negative, positive, negative. Okay, your negative, positive, my mistake. Yeah, well, negative, positive. Okay, thank you so much, Sunflower. You are the best. You are the bestest, Sunflower. Okay, you are the bestest. So our first term, what do? We, like I said, to get the first term for the first bracket, we take the cube root. Cube root of x cubed is x. Cube root of 8 is 2. Minus sign still stays as the minus sign from the original expression. Our trinomial bracket, we simply square our first term. When you square your first term, you get x squared. Guys, remember that x times x squared gives you x to the power 3. So that's why we square our first term. Then for your last term, you square the last term. When you square 2, you get 4. Remember guys, that 2 times 4, a negative times a positive gives you a negative, and 2 times 4 gives you 8. So it makes sense that Sunflower corrected us so well. I would have probably also picked up that sign error that I made, because when I would have checked, when I square the last term here, I get the square of 2 is 4. And obviously the sign, a negative times what gives me a negative? It has to be a negative times a positive. But thank you so much, Sunflower. I so much appreciate you. Like I would, oh my goodness, you are the bestest. Then to get the middle term, all we do guys is we take the first term and the last term. Don't worry about the sign. Just take this x and the 2 and you multiply. What's x times 2? That gives us 2x. We are done, guys. Done factorizing this cubic expression. X cubed minus 8. Done. Finished. All the marks in the bag. We cannot factorize this any further. We can't factorize this any further. We are done. And that is it. Okay. So I hope for anyone who is like, how do we do cubic factorization? You now sort of like have remembered what we ought to do. And even Sunflower, you can see Sunflower is on top of her game. She is very much aware of what needs to be done in these types of factorization. So that's cubic. So we can put a tick next to cubic, because even though we have all these types of factorization, but cubic factorization has been sort of like covered there, right? So I'm going to just make up another example for cubic factorization, because in the next problem it's not cubic factorization, it's something else. Let's look at something else. Let's just say we had y cubed minus y cubed minus 27. Okay, and we were asked to what? To factorize this. So y cubed minus 27. So once again, we can see, is there a highest common factor? Because we always ask ourselves that question. Is there a highest common factor between these two terms? How many terms are there? There are 2 terms. Is there a highest common factor? Yes, there is. It's 1. But 1 does not have like real significance, okay? 1 as a highest common factor does not really have great significance. So what we do then is we open 2 brackets. One that's a binomial bracket, and the other one for a trinomial, my trinomial bracket. So the binomial bracket, I'm going to put a minus sign, seeing as though there was a minus sign already. Then I'm going to put plus. This is always a situation, guys. Whenever you have a negative sign between the 2 terms and it's cubic factorization, you can see this is a perfect cube, this is a perfect cube. Remember, y cubed is a perfect cube. 27 is also a perfect cube. So this is a difference of 2 cubes, and therefore we open 2 brackets, 1 binomial, 1 trinomial. Okay, then original minus sign in the first bracket, and then positive, always the case. Then you take the cube root of y cubed. The cube root of y cubed is y. Populate the first term. The cube root of the second term, 27. Cube root of 27 is 3. Okay, you populate the 3. Then y, you square the y, you get y squared. You square the last term for the last term, square of 3, you get 9. And indeed, the negative times a positive does give you that negative sign. So that sign is 100% spot on. Then how do we get the middle term? We forget about the sign and we just take the y and the 3 and we multiply, guys. We just multiply and we put in what we get. What's y times 3? It is 3y. Done. Finished, guys. Cubic factorization at its best. Okay. Cubic factorization at its best. Let's just do one more. Let's say this time round we didn't have a minus sign, but we had a plus sign between the terms. 8x cubed 64y to the power 3. Okay, yes, I'll be going to that. Just hang tight, guys, hang tight. Okay, I'll be going to that. So 8x cubed plus 64y cubed. Okay. Yes, it was y cubed minus 27. Okay, if it was plus, remember, okay, I'll do one where it's plus. Okay, so I'm doing one now where there's a positive sign in between the terms. Okay, so first and foremost, when we look at this, we have 2. Okay, let's just say this was, let's put a 6 there. 8x cubed plus 64y to the power 6. So first and foremost, we want to establish, are these perfect cubes? Yes, 8 is a perfect cube, x squared is a perfect cube, 64 is also a perfect cube, y to the power 6 is also a perfect cube. So what we are going to do then is we are going to first check, is there a highest common factor? Okay, and yes guys, highest common factor is there. We do have a highest common factor. You know, we do indeed, and the highest common factor is what? It's 8. So we take it out, we write x cubed plus 8y to the power 6. Okay, so we take that out, the highest common factor, because remember, for any problem, that's what we always ask ourselves. Whenever we look at a particular problem, we always ask, first and foremost, how many terms are in the expression? There are 2. And then secondly, is there a highest common factor? We always follow it up with that. Is there a highest common factor? If there is, we take it out. Then I'm sure you guys can see that on the inside, we still are left with a perfect cube. X cubed is a perfect cube. 8y to the power 6 is also a perfect cube. So we are going to say 8, open a binomial bracket, open a trinomial bracket. Then remember, the sign here is plus. Then what we do is we say plus minus plus. Okay, so you see, unlike the minus bracket, I mean the minus, when there's a minus between 2 cubic terms, you know, you remember the signs, we said minus plus plus. But now when there's a plus sign, we say plus minus plus. And just like Sunflower said, she said the last term is always positive. Doesn't matter if there's a minus sign or a plus sign. The last term is always positive. And she couldn't have been more spot on than that. Okay. The only difference is that when we have a plus sign, we seem to have a negative sign, which is basically the sign for the second term in our trinomial bracket. Okay. Whereas with the minus sign, we had 2 positive signs inside our last term bracket. Thank you so much, Mbali. Really appreciate that ice cream. So let's take the cube root. The cube root of x cubed, guys. Cube root of x cubed, you get the cube root, not the square root. The cube root of x cubed is x. So we populate that with x. Then the cube root of 8x to the power 6. Okay, so when you were in grade 9, you guys should have learned that when you apply the cube root to a product of a coefficient and variable, it applies to both the coefficient. In other words, you would find the cube root of 8 and you would also find the cube root of x to the power 6. What you do is you divide the exponent. When you apply the cube root to a variable that has another exponent, it's like you are dividing the 6 by 3. That's how you remove the square root. So therefore the answer will be 2x to the power 6 divided by 3. That's equal to 2. So that's 2x squared. Hope you guys understand that. That is 2x squared. Okay. No, actually, sorry, not x. It would be y because we have y. Sorry, my bad. That's y. Okay, so that would be 2y squared. Okay. Hopefully that makes sense. So we have 2y squared. Okay. That is the cube root of 8y to the power 6. It gives us the cube root of 8. We get 2. We apply the cube root also to the y to the power 6. So it is y squared. Then for our last term bracket, guys, x times, you square the first term, you get x squared. Okay, I hope that makes sense. You square the last term, you get 4y to the power 4. Okay, which makes sense because 2 times 4 gives you 8. y squared times y to the power 4, you keep the base, you add the exponents. 2 plus 4 gives you that 6. And then remember, to get our middle term here, we multiply the x and the 2y squared, not considering the sign. We get an answer of 2xy squared. And that is basically our finale answer. Right, guys, I hope that cubic factorization is clear for you. So the signs for each respective bracket, guys, it's just straightforward. Whenever there's a plus in between the two terms, it's always going to be plus, minus, plus. Always, guys. Plus, minus, plus. Always plus, minus, plus. Always plus, minus, plus. But then if there's a minus, guys, in between the two terms, it's going to be minus, plus, plus. And like Sunflower told us, the last term doesn't matter what factorization you're doing. For your trinomial bracket, your last term is always positive. All right. So when there's a plus sign, it's just the only difference is that there's a minus sign for your middle term, whereas for your minus sign, there's a plus sign for your middle term. But in the binomial bracket, it always is the sign of the original expression. So if it was minus, this one will be minus. If it was plus, it will also be plus for your first binomial bracket. So yeah, that is basically cubic factorization in a nutshell. If there's any other type of factorization that can be done before you get to this stage, please do it. If there's a highest common factor, please do take it out, because that's how you are able to factorize fully. When we factorize fully, we make sure that there is no longer any other type of factorization that can be done. If you look at this binomial bracket, I can't factorize any further. If I look at this trinomial bracket, there's nothing more I can do to factorize. That's what we mean by factorizing fully. There shouldn't be any room anymore to factorize anything anymore. All right. Okay. That was cubic factorization. I looked at the two different types that can come, and I'm sure you've noted them. So let's move on to the next question that was there in the test. It was 2x cubed. We were supposed to factorize 2x cubed plus x squared minus 6x minus 3. Okay, so if we look at how many terms we have here, we have 1, 2, 3, 4 terms. How many terms do we have? 4 terms. Is there a highest common factor out of all 4 terms? No. But since this is an even number of terms, it means I can group. Okay, we can group terms and check, is there highest common factor, so that we can establish what we refer to as a common bracket. Common bracket. I think Mrs. Zulu was actually inferring to that. The second bracket, yes, this one. No, Miss Zulu. This second bracket cannot be factorized any further. All right, it cannot, because you're gonna look for the factors of 4. All right, now factors of 4 and 1, it's gonna, when you add together, give you -2. No ways. 2 and 2, no ways. And remember, if the positive sign for the last term is there, it means that in your brackets you're supposed to have you're supposed to have negative signs for your bracket. You know, so that this cannot be factorized any further. This cannot be factorized any further. In fact, in all cubic factorization, your last bracket cannot be factorized any further. If you have done the highest common factor factorization, if there is a highest common factor, you'll actually find that when you go on and factorize using cubic factorization, your last bracket can never be factorized any further. Doesn't matter what problem it is, your last trinomial bracket is never factorized any further. Okay, so anyways, let's come on here. 2x cubed plus x squared minus 6x minus 3. This is a grouping type of factorization. Okay, so this one, we are now going to enter into this world, apply grouping. Okay, now we don't have to literally write brackets around what we are grouping. You just need to know mentally, okay, this one I'm going to take out the highest common factor. From these two, I'm going to take out the highest common factor. So let's first look at these two. The highest common factor. When you take out the highest common factor, guys, remember we take out the highest common factor sign, we take out the highest common factor number, we take out the highest common factor letter. Highest common factor sign, highest common factor number, highest common factor letter. And some of you may be asking, why highest common factor sign? Guys, remember that if the first term of whatever you are factorizing is negative, you need to take out the negative sign as a highest common factor. Hence, I'm saying you take out the highest common factor sign, you take out the highest common factor number, you take out the highest common factor letter. So let's look at these first two. Highest common factor number. Highest common factor sign. Obviously, the first term is positive, so I know whatever highest common factor I'm taking out will be positive. Highest common factor number, 2 and 1. Highest common factor number between 2 and 1, it's 1. So I know it's positive 1. Then highest common factor letter, x cubed and x squared. When we take out the highest common factor letter, we take out the common bracket that has the lowest exponent. The common factor variable that has the lowest exponent, that is x squared. So it's positive 1x squared that I'm taking out. What gets left inside for the first term? If I took out x2 of these x's, I need 3 of them. How many must be left? All right, obviously first and foremost there's the 2 that is left, and then how many x's must be added to get 3 if I took out 2? 1. Okay, so I have 2x. Then x squared times what gives me plus x squared? It's plus 1. Okay. Yes, Sunflower, Samuel Matthews, Mbali, thank you so much for the ice cream. You are so kind. Then let's look at these last two. Negative 6x minus 3. Common factor sign. The first term for what we want to take out is got a negative. So a negative sign is the highest common factor. Common factor number between 6 and 3. Obviously, you guys have said it. It's 3. So it's negative 3 that you are taking out. Common factor letter. Is the variable common? No, it's not. So we don't take it out. What's left inside? What's left inside? Negative 3 times what gives me? Negative 6. It has to be positive 2. And then the x is there, so I didn't take it out, so it has to be there. Negative 3 times what gives me negative 3. Obviously, a negative times what gives me a negative, it's a positive. 3 times what gives me 3, it's 1. So it's 2x plus 1. Look at those common brackets. So now from grouping, taking out the highest common factor for 2 pairs of terms, I must once again take out a highest common factor what? Bracket. So now I'm going to take out the highest common factor bracket. I have 2 terms now. 1, 2. The highest common factor bracket is what? 2x plus 1. What gets left behind on the left? If I took out the 2x plus 1, what's left behind on the left? You can see what's left behind on the left, guys. It is x squared. What's left behind on the right? I have negative 3. So that means 2x plus 1 into x squared minus 3. Can I factorize this any further? Okay, this is 2x plus 1. This is x squared minus 3. Guys, this is where I end. Okay, this is where I end. Okay, right, sure, look at that. All right, so that was nice, wasn't it? Very neatly done, very smoothly done. Like, I mean, you could swear we are pros in this thing, right? We are so much pros. Okay, so guys, please, right, in the question paper, they only looked at cubic factorization and they looked at grouping factorization. But also, since grouping encompasses highest common factor, we also covered highest common factor factorization. But remember, guys, there's these other 3 types of factorization that you also need to be very good at. You are very right, Mrs. Zhu. Dots, difference of 2 squares factorization, you guys need to be spot on with that. And remember, difference of 2 squares factorization, let's say I gave you, I'm just gonna give you out of the top of my head, x to the power 4 minus y to the power 4. You look at this first term, this is a perfect square. Why do we call this a perfect square? It's because it's a variable raised to a even exponent. So this is a perfect square. This here, y to the power 4, this is also a perfect square. Why? Because it's a variable raised to a even exponent. Guys, when a variable is raised to an even exponent, it is called a perfect square. Please take note of that. A variable raised to a even exponent. Variable raised to an even exponent. I mean, you guys need to know what a perfect square number is, but now more than just knowing what a perfect square number is, please take note of what a perfect square variable is. It's when a variable is raised to a even exponent. Okay, so this is a difference minus of two perfect squares. Difference of two perfect squares. I repeat, this is a difference of two perfect squares. Why? Because this variable is raised to an even exponent, and this variable is also raised to a even exponent. Okay, all right, now let's go. When we factorize, we ask, is there a highest common factor? Let's start there. Is there a highest common factor? No. Of course there is. It's 1. But that 1, when we take it out, it does not really significantly change anything. We know that we can just open two brackets. We know that the 1 is outside. It's there, even though we don't see it. What then do? We take the square root of x to the power 4. The square root of x to the power 4 gives us x squared. Because remember, the square root simply means we divide the 4 by 2. So therefore we get x squared times another x squared. We get x to the power 4. We do the same thing with y to the power 4. What is the square root of y to the power 4? The square root of y to the power 4 is y squared. Okay, the square root of y to the power 4 is y squared. So then obviously we put y squared and another y squared. So you can imagine, guys, x squared times s squared gives us back the x to the power 4, of course, because the square root of y of x to the power 4 is x squared. Okay, then the square root of y to the power 4 gives us y squared. So y squared times another y squared will give us back the y to the power 4. Then because there's a difference, remember, this means that we have different signs inside our bracket. Okay, and what I'm saying now is that you always, by convention, and this is what I always encourage my learners, please always put the plus sign first and the minus sign last. Why? Because if there's any further factorization, it will happen where the minus sign is. Okay, if there is any further factorization, it will happen where the minus sign is. Okay, now someone may think, yes, I'm done, and then they underline and they say they are complete, but you are not done, guys, because if you look at the first bracket, we can't factorize any further. But look at the second bracket. Okay, yes, Landy with 38. The second bracket can be further factorized. Why? Because this is a difference of what? Of two perfect squares. That's why. So we can factorize this further, which means we are going to hold the first bracket for now. Then we are going to open two brackets. Why? Because of this last bracket. Hence, I was saying to you guys, it's of utmost importance that for your last bracket, you keep the negative sign. Please do that for me. Don't put the negative sign front at first. Put it in the at last, so that you retain the first bracket because it has plus. You know, the sum of two squares, we can't factorize any further. But a difference of two squares, it's a type of factorization which we are looking at now. We need to make sure that we actually attend to it. X squared is a perfect square. Why do you say x squared is a perfect square? It's because it's a variable raised to a even exponent. This is an even number. Y squared is also a perfect square because it's a variable, meaning a letter, raised to a even exponent. So what we do is we simply put the square root of x squared is equal to x, so we put x and x. Then we ask us that the square root of y squared, that's equal to y, so that is y and y. And then after that, guys, all we do is we put in the first bracket plus, and then we put a minus. Thank you so much, Mbali. You are an amazing mother. If you are tuning in here to help your daughter out, Chonga, you are next level mother. You are a true mama bear. You are a true mother bear. So x squared plus y squared into x plus y into x minus y. Okay, all right. I hope you guys understand this. Okay, that if we can still factorize further, we don't stop, we go on. Because some people lose marks because they simply end here. They're like, yo, I'm done. They do difference of two squares and they're like, yeah, I'm done. But they don't take note that yes, is still some further, okay, difference of two squares that you can do. Okay, you can still factorize further. Okay, Richie, you're saying, can you explain the first bracket? Which first bracket? This here is a sum of two perfect squares. All right. In factorization, we know that a sum of two perfect squares cannot be factorized. Okay. So we simply leave it as x squared plus y squared. Whereas a difference of two perfect squares can be factorized further, and that is by taking the square root of the first term, taking the square root of the last term, and then obviously putting a positive for the first bracket and a negative for the second bracket. Okay, so we cannot factorize a sum of two perfect squares, cannot be factorized. A sum of two perfect squares cannot be factorized. It is unfactorizable. But a difference of two perfect squares, it is factorizable. And how do we factorize a difference of two perfect squares? We simply open two brackets. We take the square root of that first term. We write whatever we get in the first term of each bracket. And then we take the square root of the last term. And we write whatever we get as our last term for each bracket. And then we populate the positive and the negative sign in the respective brackets so that we can then be able to get to our answer. So we did first apply difference of two squares to the original expression. That's where it got us these first two brackets. But then we realized that the last bracket can still be factorized further. So we keep this bracket as it is, x squared plus y squared. We don't do anything to it because it cannot be factorized. And then we take this last bracket and we go ahead and apply. What is the square root of x squared? It is x. That's why we populate the first term of each bracket with x. What is the square root of y squared? Okay, without the negative sign, just the square root of y squared, it is y. So that's why we populate y as our second term for each bracket. And then in the bracket, for each bracket, we put plus for the first bracket, then minus for the last bracket. And that's done and dusted. We cannot factorize any further, so we stop right there. Okay. Then I think there was another question for factorization. X squared minus x to the power 4 minus 16. I guess there was a difference of two squares, another question there. But maybe what I can do, just for the benefit of the masses, all right, I'll look at two trinomial questions. Just so that you guys can get a pretty clear idea. So this is a trinomial expression, and I need to factorize it. Now, when you look at this, first and foremost, you need to look at it. And when you look at it, you're like, okay, is this a trinomial I can factorize? And there's things that you need to take into consideration, because we need to somehow know, okay, 2 here is a positive number. All right? And the 3 is an x term. Okay? X squared is x squared, guys. It is an x squared term. So this is a quadratic trinomial. Okay? It's a quadratic trinomial. We can find the factors of 2. These factors of 2, when we multiply them, obviously will give us the 2. Somehow when we add those factors of 2, they need to give us the coefficient of the x term. I repeat, the factors of 2, we need to first find them, because when we multiply them, we get that 2. Alright, so when we multiply, we get the 2. When we add those factors, we must get the coefficient of the middle term. Now, what I usually say to learners is that this plus sign for the constant actually says something. It means same signs in bracket. But then you ask, if the plus sign means for the constant or the non-x term, the plus sign means same signs in the bracket, what will be the signs inside the bracket? The sign will be in accordance to the coefficient of the middle term. So if this is a plus sign, then it means inside my brackets I'm going to have 2 plus signs. And Landiwe just says something that I usually say when I teach this so that I can help people remember. I usually say that this plus 2 is like the father in the household. Yeah, you know, the father of a household is supposedly the head of the household. If the father does exist and he plays his role, then it's father supposed to be the head of the household. And you would think that the mood of the household will be determined by the father. But you know what? There is the fearless, unwavering mother, the middle term, who basically ultimately determines the mood of the household. So if the father is positive, okay, right? Let me just say it this way. This plus sign would probably say, okay, this is the mood of the household. But if the mother's mood is not like if the mother's mood is not in agreement with the father, then you must know that that's basically how it's going to be in the house. And anyone who has lived with their mother in the household and their father will know that if the mother is not doing well, then you must know the entire household is not doing well, because the mother's mood dictates, the mood of the day. Anyways, so like I said, plus means same signs inside the bracket, inside the household, but according to whose mood? According to the mother's mood. So if the mother is positive, then everyone in the household will be positive. If the mother is negative, guys, everyone in the household will be negative. Mrs. Zul, that's exactly the point. So that's why I said, and that's why Landiwe has been in a previous lesson that I've taught, where I've mentioned that this sign, okay, is the mood of the mother. But the father says it's the same mood inside the household. But according to who determines the mood? It's the mother. So same signs, but according to who? According to the mother. So plus means same signs. Okay? Plus means same signs. According to who? According to the mother. So this plus sign, according to the mother, that's the same signs that are inside the bracket. X squared, obviously x and x will give us our x squared. And then, like I said, the factors of 2, guys. The factors of 2. Okay? 2 is a prime number. It only has 2 factors, 1 and itself. Okay? So that's 2 and 1. Or you can put the 1 this side and the 2, doesn't really matter. Okay? So when we multiply these 2 numbers, we get 2. When you add plus 2 and plus 1, you should get the coefficient of the middle term. And that's it, guys. Now, someone was asking me in the comment section, what if the constant is negative and the coefficient of x is positive? Check it out. Here we go. So once again, negative sign. What the negative sign says, then the minus sign, or the minus constant, or the negative constant, if you will, says different signs, not same. different signs. Already, when we did difference of two squares, you saw, guys, that when the last term is negative, it's different signs. But now, it's different signs, right? But this time round, the mother says the following: the highest factor from the factors of 4 will have the mood of the mother. Okay, so the mood of the mother is positive, so the highest factor will actually adopt the mood of the mother. You could say the firstborn son or the firstborn daughter will always be aligned to the mood of the mother. All right, because those factors are like the kids. Okay, so you make one bracket positive and the other one negative, but remember, the one that will be positive in this case will have the highest factor out of the factors of 4. Okay, so that's why in this case, if you write x squared plus 3x minus 4, the two brackets are there. You know the factors of 4, you have 4 and 1, you have 2 and 2. All right, but what did we say? The highest factor will have the sign of the mother. So that means plus 4 minus 1 or plus 2 minus 2. In this case, obviously, these factors are the same. So it would never be the factors that are the same. This one is completely out. Okay. But for here, okay, the highest factor will have the mood of the mother. Yeah, twins are out because plus 2 minus 2 gives us 0. When we add these, remember, when we multiply them, we need to get the constant term. When we add these two, we need to get the coefficient of the middle term. Does that make sense? So when we add these two, we need to get the coefficient of the middle term. When we multiply these two, we get the constant term. So this one is qualifying, and it's qualifying very well. So that's why we know that even from the fact that we have factors, this means that this trinomial is factorizable. Okay, Mrs. Zhu, I wanted to go back to a question you had asked earlier on about can we factorize this one, this last bracket, when we are doing cubic factorization. This last bracket, can we factorize it? Okay, the additional reason why I know this cannot be factorized, remember, what did you say about the last term? If it's positive, it means same signs inside the bracket. According to who? According to the mother. But if we have same signs, the factors of 4, which we multiply, give us 4, but when we add, give us negative 2. Can we ever have? No. So that's why I'm saying we cannot factorize this one. It's like I know we cannot factorize it because the factors are not there, you know. But for this one, you know, the factors are there. I do have factors because I know plus 4 minus 1 will give me the positive 3. When I multiply these two, I get the negative 4. So they are there. Okay, so I write x squared, that's x and x. The signs I know very well as well. I have plus there, I have minus there, and then of course I already determined the sign, because the sign that has the highest factor will get the sign of the mother. So it's plus 4, it's minus 1, and that is done. Okay, and I know my factorization is 100% correct. I didn't even guess. There was no guessing game. It's straight on point. It's on point. It's exactly what is supposed to be there. Okay. Okay. Caleb, you said go back quickly. Where do you want me to go back quickly? Okay, because I was just doing this thing, x squared plus 3x minus 4, the factorization. X squared plus 3x minus 4. Like I said, guys, that if the last term, is negative, okay, all that means, guys, if the last term, the constant, is negative, it just means that the minus sign says that we're going to have different signs inside our bracket. That's what it means. Then you look at the sign of the middle term. It's positive. So that means basically that the sign of the middle term, guys, will be adopted by the highest factor. The highest factor will have the mood of the mother, okay? And then basically you find the factors of negative of 4, okay? You write them down. I have 4 and 1, you have 2 and 2, but obviously 4 and 1 will be the one that will qualify. The mood of the mother, the biggest daughter, then the little son will not have the mood of the mother. Then of course you can see that 4 minus 1 does give you 3. The 4 times the negative 1 gives you negative 4, so that works. Okay, that works very well. Caleb, I think, guys, some of you just will have to revert and go to my YouTube channel if you want to get the explanations of some of the things that I've already done. Okay, yeah, okay. Then x cubed plus 64y to the power 6, like I said, this is a sum of 2 cubes, cubic factorization. But before that, we can see, is there highest common factor? Because with all factorization, before we start with anything, before we factorize, we must ask, is there highest common factor? So there was, we took out 8, okay, and we wrote x cubed plus 8y to the power 6. And then we can see that we can now apply cubic factorization to what is in the brackets. And we go ahead and do that, okay? Or you wanted to copy it down. Well, you should have said, okay, I'll do one last one. But that's not under trinomial. Someone said do difference of 2 squares. X to the power 4 minus 16. What type of factorization is x to the power 4 minus 16? So those who are aware will see that, oh, okay, x to the power 4, this is a variable raised to an even exponent, so this is a perfect square. So I have a perfect square here. 16 as well is a perfect square. And then minus is a difference, so I have a difference of 2 squares. It's Maths is a Game on YouTube, guys. It's also Maths is a Game. You can go to my bio. The link is there. There's a YouTube link in my bio. The only link that is there. Just click on the link. You can go and subscribe there. I will be uploading this session onto that channel so that you can watch it at your own time. And if you have questions, you can always inbox me and let me know what your concern is. Okay. X to the power 4 minus 16. So like I said, these are perfect squares. So there's no highest common factor besides 1, which has no significance. So I can open my 2 brackets just like that. What is the square root of x to the power 4? It's x squared. So we write x squared and x squared. Then what is the square root of 16? That's 4. So we write 4 and 4. And then you remember what I said. I said it's better to write the plus first than the minus last. Now you have a sum of 2 perfect squares, but we can't factorize that, so it stays like that, x squared plus 4. The last bracket, we have a difference still of what? 2 perfect squares. So I go ahead and I factorize even further, x and x. The square root of x squared is x and x. The square root of 4, 2 and 2, plus, minus, done. Okay, remember, if factorization is still possible, I go ahead and I factorize even further. And then I end when factorization can no longer happen. Now, as you can see here, I cannot factorize any further. I stop right there. Okay, sorry about that, guys. Is it over? Yeah, I'm still here, guys. Sorry about that. Just had a bit of a situation here. Had to attend to very quickly. That's what happened. But yeah, I think that basically is that question where that factorization is concerned. Guys, I will encourage you that if you guys feel like there's a sections, for instance, with the factorization that you are not getting very well, you can always go and check out the YouTube channel, please. All right. Okay. Unfortunately, for those who are saying other things, I have to actually there's a question paper that I'm answering at the moment, so I'm covering certain bases. All right, so you're just gonna have to bear with me. I think there's 2 questions with expand. Okay, so expand or simplify. So I'm gonna do those questions. All right, now, no problem. Expand or simplify, and then after that there's equations that follow that, and then trigonometry. So I'm just gonna go in the order of that. And then, like I said, if you guys have other questions and maybe you have other sections that you want help with, unfortunately, I'm not going to be able to do everything tonight. That's for sure. Rest assured that will not be feasible. But I will do what I can now today. So here with this one, guys, we have a binomial by a trinomial. Okay, so obviously the opposite of factorize is this. Okay. Okay, so 2x minus 1 into x squared minus 2x plus 1. So obviously this is us applying the distributive law. Take 2x, you multiply x squared, 2x, you multiply by negative 2x, you take 2x, you multiply by 1. Remember, when we distribute, guys, this is very important. You must distribute using S, N, L. In other words, you start by multiplying the signs, you multiply the numbers, you multiply the letters. And you can do that very efficiently and very effectively. And when you do it, please do it so that you can be able to achieve the end. So 2x times x squared, positive times a positive is positive. 2 times 1 is 2. X times x squared. Remember, with exponents, whenever you are multiplying same bases, you keep the base, you add the exponents. So there's a 1 here. You know that's x to the power 3, because 1 plus 2. You keep the base, you add the exponent, so it's 2x to the power 3. Then you go and multiply 2x with minus 2x. Again, you apply S and L sign, positive times a negative. Negative 2 times 2, 4, x times x, x to the power 1 plus 1, remember? So that's x squared. Okay, then you move on again. 2x times positive 1. Positive times a positive is positive. 2 times 1 is 2, and the x is attached to the 2. So 2x has finished its run distributing itself to all 3 terms. Then negative 1 has to get a piece of his share, getting a piece of everyone else on the other side. Negative times a positive, that's negative x squared. Negative 1 times negative 2x, negative times a negative is positive. 1 times 2, the number is 2, then the x follows. Then you have negative 1 times positive 1, negative times a positive is negative, and 1 times 1 is 1. Okay, now you add the like terms. 2x cubed is unique, it does not have a like term. Negative 4x squared and minus x squared, they have like terms. Negative 4, so minus 4 minus 1. Remember, when we add like terms, we keep the variable and we add the what? The coefficients. Negative 4 minus 1 is negative 5. Then 2x plus 2x, those are like terms, you get 4x. And then last but not least, negative 1, that's a constant term. You cannot add any other terms together. Remember, x cubed, x squared, and x are not like terms, so you leave your answer like this. You cannot add anything further. this is how your final answer should then look like. You cannot do anything more than what you see here. Okay, so hopefully we know how to do this, and we do it well, and really it's not a problem. Number 2, 3x plus 5, the whole thing squared. I hope we all know that we do not apply the square to the first term and apply the square to the last term and we say we are done. No, we open 2 brackets of 3x plus 5. Please, people, otherwise if we do anything that's different from that, then we are doing something that's completely off and wrong. So we open 2 brackets of 3x plus 5, and then we FOIL using S and L. In other words, we distribute. First term, 3x times 3x, we get 9x squared. Then 3x times 5, we get 15x. 5 times 3x, we get another 15x. And then 5 times 5, we get a positive 25. Final answer, 9x squared. 15x plus 15x gives us 30x plus 25. We cannot add unlike terms, so we end right there. Okay. (5a minus 2b to the power 3). Okay. So with this type of question, we open 3 brackets of 5a minus 2b. We keep the first bracket, and then the last 2 we FOIL. Alright, so that at the end we can have a binomial by a trinomial which we can multiply out, and then we can get the answer. So that's the strategy. We keep our first bracket as it is, untouched, and then we go ahead and we multiply out what's here using S and L. 5a times 5a, 25a squared. 5a times minus 2b, positive times a negative is negative. 5 times 2 is 10. A times b is ab. Okay. Minus 2b times 5a minus 10ab. Maybe not, Maybe not, but I will tell you one thing. It helps, it's like, for instance, do you get marks for opening these brackets? The thing is, some people fall into the trap of squaring the first term and squaring the last term. So what opening 2 brackets does, it makes your mind remember, oh, I actually have to FOIL. Okay, so in the same way, opening 3 brackets helps your mind remember, oh, I have to retain the first bracket and FOIL the last 2 brackets. Okay, so that's just the strategy to help you remember what ought to be done. But if you feel that you are comfortable, you have no problem, then I guess, yeah. But opening these 3 brackets actually helps, with you knowing what ought to be done. Because how sad it is, I've seen too many learners, they say 5a minus 2b cubed, and then they apply the cube to the 5a, and they apply the cube to the minus 2b, and they're like, I'm done. And then when the paper returns to them, and they've gotten a big fat 0, they don't believe what they have done, and they don't believe that they actually did what they did. So hence I insist on the opening of the 3 brackets so that you can know what needs to be done. Negative 10ab minus 10ab, that gives you negative 20ab. Please guys, make sure that if you don't know what the addition of these coefficients are, take a calculator and put it down. Okay, negative 10a, negative 10a, negative 20ab. Okay, please guys, otherwise, hey, I've seen people getting marks, not getting marks simply because they don't get the addition of the like terms correctly. I've seen people say negative 10ab is equal to 0, and it's painful, man, when learners lose marks simply because they are careless and they don't take into consideration the signs. So literally take your calculator if you need to. Remember, the variable will stay the same, so AB will stay the same. What you need to do is add and subtract the coefficients. And by the coefficients, I mean the numbers before the variables. So this is negative 10a, which is equal to negative 20ab plus 4b squared. Yeah, so I like what Miss Zhu is saying in the comment section. Mrs. Zhu is 100% spot on. No shortcuts, no shortcuts. So Landio, I hope that really helps. I think you have the validation of two. Yeah, we've got a validation of an amazing teacher in the comment section there, Mrs. Zhu. I think she definitely knows it from her experience as well. Now we can take the binomial and multiply by the trinomial. So 5ab must have some. 5ab needs to have interaction with all three, and then 2b also needs to have interaction with all three by multiplication. And let's not forget S and L, sign, number, letter when we multiply out. So 5a times 25a squared, I'm sure you understand, it gives you 125a cubed. Then 5a times negative 20ab, you get negative 100a squared b. Then you have 5a, remember 5 times negative 20 gives us negative 100. A times a, keep the base, we add the exponent, it's a squared. Then the b next door, 5a times 4b squared, that gives us positive 20ab squared. Then we take the negative 2b, and it also has to have some. Negative 2b times 25a squared, negative times a positive is a negative, 2 times 5 is 50, a squared times b is a squared b. Then negative 2b times negative 20ab, negative times a negative is positive, 2 times 20 is 40. That's why I like the S and L, because negative times a negative, the sign is sorted positive. Then the number 2 times 20 is 40. Then the letter b times ab, a. Then remember, the b times b gives us the b squared. Wow, Mbali is like, Bali, thank you so much, you're too kind. Then 2b, negative 2b, don't forget the sign. Negative 2b times 4b squared, negative times a positive, the sign is negative. Then the number 2 times 4, 8. Then the letter b times b squared, b to the power 1 plus 2, that gives us 3. And guys, I know that my terms are 100% spot on, because S and L, every single thing I did, I took into consideration the sign, I took into consideration the number, I took into consideration the letter. And I know, and even if I don't know what something is multiplied is equal to, I grab my calculator, I punch it in, I get the answer. Okay, now let's look at the like terms. Negative 100a squared b has a twin, which is negative 50a squared b. So let's add the twins. A squared b, negative 100, negative 50. So a squared b is going to be there anyways. What's negative 100 minus 50? That is negative 150. Then 20ab squared, 20ab squared. Remember, the coefficient and the sign goes along with it. 20ab squared plus 40ab squared. So I know these need to be added together. That gives me 60ab squared. Right? There's no other like terms. I've sorted all the like terms. Then he's alone, Shem. Alone. Lonely. I am so lonely. Akon style. Has no body. All alone. They both have no body. They're all alone. Okay? Alright. There it is. Okay. Yeah. So yeah, guys, the multiplying out, the expanding, let's not forget the important things there that we need to remember. All right. I just want to do one last one with expanding and multiplying out, because there's something I want to check. Okay. Just this last one, and then definitely we'll move on from this now. Multiplying out and expanding. Okay, it's just important pivotal skills that I'm hoping that the learners have rogered down. You see. Okay, so this one, how many terms in the expression? We have 1. The minus sign separates this term. 2 terms. So x minus y obviously is squared. Say are the terms with AB, these ones. Yeah, this is a squared b, remember? And this one is ab squared. So these are unlike terms because this is a squared. This one is a. Remember, if the exponents are different for the same variable, those are unlike terms. So we can't do anything. We can't add these. We can't do anything. These are unlike terms. This b has an exponent that is 1. This b has an exponent that is 2. So these are unlike terms. So there's nothing more we can do. We end right there because they are unlike terms. Okay. Yeah. Water and the fish oil, they have different densities. So one floats on the other. They don't particularly become a solution, if you will. Minus 3 into x plus y into x plus y. Remember, BODMAS says we start with brackets, so we are going to do the FOIL for x minus y into x minus y. We get x squared minus xy minus xy plus y squared. So guys, I just went fast here. X times x is x squared, first term. Outer term, x times negative y gives me negative xy. Minus y times x gives me negative xy, another negative xy. And minus y times minus y. A negative times a negative gives me a positive. Y times y is y squared. Minus 3. Now, I multiply out what's in there. X squared plus xy plus xy plus y squared. So once again, I foiled. X times x is x squared. X times y is xy. Y times x is xy again. And then y times y is y squared. Okay. Now this 3 is waiting patiently for everything in the bracket to be sorted, and then this negative 3 is waiting to be distributed. So we retain the bracket here, guys, because the relationship of negative 3 with this bracket is one of multiplication. Okay, and this is very important. Okay, so minus xy gives us negative 2xy plus y squared. And then let's just resolve what's inside here, because xy plus xy gives us positive 2xy. Then this negative 3 is just waiting to be distributed. So let us finally distribute it. Negative 3 times x squared gives me negative 3x squared. Because the negative times a positive is a negative. 3 times 1 is 3. And then the x squared next door. We just put the x squared. It combines with the negative 3. Negative 3 times positive 2 is negative 6xy. And then negative 3 times positive y gives me negative 3y squared. Very important what happens here. The retention of the term outside the bracket awaits for things to be resolved inside the household. When things are resolved inside the household, multiplication takes place fully and completely. The negative 3 is ever ready to be distributed inside, changing the situation inside that household and ensuring that at the end now we have terms that we can add and subtract. So we can now add and subtract the terms. X squared has a like term, it's negative 3x squared, and yes, Mrs. Zulu, you are spot on. We get negative 2x squared from x squared minus x squared minus 3x squared. Then negative 2xy and negative 6xy are also like terms. Negative 2 minus 6, we get negative 8xy. And then last but not least, the y squared minus the 3y squared. Y squared, that's positive, minus the 3y squared gives us a negative 2y squared. And that is basically our answer. We cannot add any of these together. Doesn't matter that there's a y there and there's a y squared there. Remember, the variables have different exponents, so we cannot mix or add unlike terms. Exponents, the minute the exponents for the variables are different, guys, that means those are unlike terms. We cannot add them. We may want to, we may be tempted to, but we cannot do it, however much we want to do it. Okay. Right, so I hope that resolves that very nicely. If there's any questions about any of these expansions that we did here, then people can ask, of course, but if not, then I move on very swiftly. Can we take out the negative 2? Remember, Mrs. Zhu, that here we are asked to expand or simplify. This is the simplification, all right? We have simplified till the dead end. So this answer is the simplified answer. Taking out means you are factorizing. And remember, when we factorize if only we are asked to factorize, okay? So by simplifying, it means we are writing our answer unfactorized. Remember, if there was a fraction though, and let's say this was in the numerator, your final answer, and there was something in the denominator that could potentially cancel something in the numerator, and it was that highest common factor that you took out, then you would take it out. Why would you take it out? You take it out with the purpose and the intention of simplifying. Okay, so that's why simplification, we need to check its relevance within a problem. But as far as simplified, that's what it means to be simplified. This is the simplified answer. It does not get better than this. Okay, yeah. So, but good question. Thank you for asking, Mrs. Zhu. Thank you for asking. Let's look at this one now. Okay, look at this one. Simplify. Woohoo! You could sense that people have been waiting for this one. Like, we've been waiting. We've been waiting. I just want to check if the question was actually like this. Just very quickly. Sorry, guys. I just want to... because I'm just questioning whether I wrote out the question correctly. Oh yes, I wrote it out incorrectly, definitely. So the question was 2 to the power x minus 2 to the power x minus 2 over 2 to the power x plus 1 minus 2 to the power x. So I'm sure you guys can see that this would be a question very much relevant in your simplification of exponents, right? Very relevant in your simplification of exponents, because with your simplification, or where exponents are concerned, there are those questions where you have multiplication and division exclusively, and when you have multiplication and division exclusively, then you have to change all your bases to prime bases. And then after you've changed all your bases to prime bases, what you then do is you take the respective bases and you apply law number 1 and 2, meaning you add and subtract according to where your base is situated. You would add all of the exponents that are in sort of like in the numerator, but and you would basically write down a base, maybe base 2, and collect all the exponents. If they are in the numerator, you are adding them. The minute they are in the denominator, the sign of the exponent will change. Okay, but hopefully I'll look at a question like that, because I'm seeing this one, for instance. But this one has to do with addition and subtraction. And where addition and subtraction are with exponents, guys, and there's a division in the mix, meaning this line of divide, then it means there's a type of factorization that will be there. So in this case, maybe a highest common factor, all right? But before we do the taking out of the highest common factor, we have to first look at the numerator and look at how many terms do we have. So we have 1, we have 2 terms, because a minus sign separates terms. A minus and a plus sign separates terms. In the denominator, you also have 2 terms. This is 1, this is 2. So step number 1 here is we need to split. Okay, if the bases were not prime, we would actually start there. We would change the bases to prime bases, but you can see that 2 is a prime base. In other words, it's a prime number. 2 is also a prime number here, it's a prime number there, it's a prime number there. So the next step then would be to split the bases. So we split bases. In other words, we apply the reverse of law number 1 of exponents. So 2 to the power x, there at the top, 2 to the power x times 2 to the power negative 2. Do you see what I did there? This 2 to the power x minus 2, I wrote it as a split up base in that it's 2 to the power x times 2 to the power, look at the exponent there, negative 2. Okay, bases are the same. I can re-add these exponents if I want to get this exponential state that I had originally. Okay, so what I did is I split the bases. So I do that at the top and then I do that at the bottom as well. This is 2 to the power x plus 1. I'm going to write it as a split base, 2 to the power x times 2 to the power 1 minus 2 to the power x. Okay, so I do this, guys, when there's an addition and subtraction, but I can clearly see that the bases have the same coefficient for the variable x. That means I can split the bases, and then after that I can take out a highest common factor with a base raised to that variable and that particular coefficient. Okay, so that's why I'm saying you split the bases first, because addition and subtraction, you cannot move in this question unless you first factorize, because there's a plus and a minus sign separating the bases. So I split the bases, then I take out a highest common factor, which in most cases is the variable, the base with the variable exponent. In most cases, that's not in all cases. So if we take out 2 to the power x, because it's common, there's 2 to the power x on the left, 2 to the power x on the right. If we take it out, what gets left behind on the left? 1 minus what gets left behind on the right. We have a 1 in the place of the 2 to the power x times 2 to the power negative 2. Okay, that's what gets left behind on the right hand side. Let's look at the denominator. What do we take out? The 2 to the power x. What gets left behind in the left hand side? We get left with 1 times 2 to the power 1 minus, what do we get left behind on the right? With 1. Okay, and then I'm sure you guys can see, after taking out the highest common factor, you can see that 2 to the power x. Cat Chris, I guess you just didn't you find yourself in my comment section in one of the videos as well, Cat Chris? It seems like you are very, I don't know, maybe it's a sign. Maybe Maths is calling you. I don't know at what stage of your life you're in, but it seems like Maths is calling you. And I think I actually commented on your comment, right? Oh man, that's funny. Yeah, well, thanks for joining in anyways. Or maybe I'm supposed to be a recipient of your generosity. All right, so 2 to the power x and 2 to the power x in the numerator and the denominator, guys, that will cancel. We can cancel. Why? Because cancellation can happen as long as it is not across an addition or subtraction sign. Oh man, I actually meant that as a joke, but thank you so much. I won't complain. To be a recipient of your generosity is a joy. Thank you so much. Really appreciate those 5 roses, Cat. You cancel those two, but remember, when we cancel, guys, we actually are dividing 2 to the power x with 2 to the power x, which leaves us with 1, right, at the top and the bottom. Then we have 1 minus 1 times 2 to the power negative 2. That's simply 1 over 2 to the power 2. Okay, actually I'm going to write it down further. Then 1 times 2, there is 2 minus 1. I just want to write this out. 1 minus 1 over 4 over 2 minus 1. Guys, this is very important, actually writing this out, okay? Because what your teacher wants to see is to see you being able to actually write it out, okay? Remember, 2 to the power negative 2, a to the power negative 1. This is what you learned, negative exponents. What did you learn about negative exponents? That if a base is raised to a negative exponent, the base changes position. So the base simply moves from the numerator because it is currently in the numerator. I want to show you guys something. If I would reveal everything that you don't see. So, okay. So what you see is a to the power negative 1. But in all honesty, what actually is there is in the denominator you have 1. You have 1 as a coefficient. So what they say, the law says, if you have a base raised to a negative exponent, the base changes position. So where was the base? In the numerator. Where does it go? To the denominator. That's why we're saying the base changes position from the numerator to the denominator. The exponent also changes. So from negative, the exponent, it becomes positive in the denominator. What is left behind? If the a leaves the denominator, the numerator, and goes to the denominator, okay, then a goes to the denominator, the exponent changes. What gets left behind is a 1. Okay, that coefficient 1. So that's why we say the answer is 1 over a. Okay, we can't say the answer is a to the power 1. That's, to say this is equal to that is not correct. Okay, so that's why, for instance, 2 to the power negative 2, we write it as 1 over 2 to the power 2, which is actually equal to what? What's 1 times that? It's actually equal to 1 over 4. Very important. Then you can grab your calculator and say 1 minus 1 over 4, which gives you 3 over 4. 2 minus 1 is 1. And we know that this answer is simply 3 over 4. Guys, it's very important that you do show this conversion from exponential state to numerical fraction state. Very important. Okay, especially here in grade 10. Okay, so please do show it, because like I said, sometimes the step marks that you actually miss out on when you don't do it, right? For some teachers, it becomes evident. If you move from here and you write the answer, it becomes evident to teachers that you simply just use the calculator so that you would avoid steps. Remember, the whole thing of without using a calculator is saying you must show your steps of how you were able to get to your answer. So please, guys, let's make it a point that we don't say goodbye to marks just like that. So with addition and subtraction of exponential expressions, let's take into consideration these steps, that either in the numerator or the denominator there is some sort of factorization that needs to be done by yourself. I just want to show you a quick question here. Okay, so once again, if you look at this question, 25 to the power x minus 1 over 5 to the power x plus 1. Now, once again, there's addition and subtraction between terms, but I'm sure you guys can see that our bases, all right, 25 is not a prime base. 1 is not a prime base, okay, because 1 is not a prime number at all. But even though that's not the case, it is just 1 here. In the denominator, we have 5 to the power x plus 1. So 5 here is a prime base, okay. So what we're going to do, okay, as I had said, even in this question, if these bases were not prime, we would have changed them to prime bases, okay. So that's where we always start. We look at the terms, we change them to prime bases if there's a need. 25 can be written as 5 to the power 2. Cheers, Miss Zhu. Mrs. Zhu, it was so good having you. Hey, thank you so much. I actually will be leaving at 10:30. No, 10:30, 11:30. I think I will have put these guys to bed. Some of you will probably be sleeping in your couches, or sleeping as you're holding your phone, or sleeping on the table. So want to let you go. You guys go at 11:30. But Mrs. Zhu, thank you so much. It was good having you. You have yourself a good night's rest. So this 25 becomes 5 to the power 2. Then we have 5 to the power 2x minus 1 over 5 to the power x plus 1. But we can't apply the splitting of the bases in this situation because we don't see a possible highest common factor. So that means now we need to look at something else, because the factorization that we applied here was highest common factor factorization, and it led to a cancellation of some sort. this particular scenario won't work. The same method won't work. So when we look at this, we look at it and we're like, okay, 5 to the power 2 is a perfect square. It's even raised to the power x, okay? And then 1 is also a perfect square. Minus, this is a difference, but it's a difference of what? Of 2 squares. So that means here I have a possible dots situation, difference of 2 squares. And it means I can factorize applying difference of 2 squares because it's 5 to the power 2x. So what I do is I swap around the 2 and the x, okay? 5 to the power x squared minus 1. And maybe you're sitting there and you're like asking yourself the question, how is that even possible? Remember, guys, that multiplication is commutative. In other words, the order in which I place 2 and x doesn't really matter. X times 2 is the same thing as 2 times x. So in this case, I use that understanding to basically set up my expression in such a way that I can factorize it. So there are two 5 to the power x's, and then this makes this a perfect square, that is a perfect square. So I open 2 brackets, 5 to the power x here and 5 to the power x. I know that if I keep the base, I add the exponent, I get that 2x back. I got 1 and 1. I put plus and minus. That's all over 5 to the power x plus 1. See that? Ooh. Now I can cancel these 2 brackets because of the factorization. And then what's my answer? What am I left with? 5 to the power x minus 1. Okay? Alright. Guys, please take note of this possible question that you could get where there's addition and subtraction of exponential expressions. Okay. All right. Okay. Then the next question that's here is one that involves addition of algebraic fractions. Okay. Is one that involves addition and subtraction of algebraic fractions. It's not an equation, but it's an expression. It also says simplify Okay, do you see this, guys? Okay, so I did a session on algebraic fraction expressions and how to simplify them, because this is like a typical addition of fractions. So with typical addition of fractions, what we need to do first, step number 1, is we factorize the denominator. Okay, remember guys, this is not an equation, it is an expression. So we need to first factorize the denominator. So our first denominator doesn't need to be factorized, it's a minus 4. Our second denominator does not need to be factorized, it's a plus 3. Our last denominator is a trinomial, it can be factorized. Minus the constant term is negative, so that means we're going to have different signs inside our bracket. The factors of 12, the highest factor will have a negative sign according to the mother. So I know the factors of 12 in this case will be 4 and 3, because negative 4 times 3 gives me negative 12. Negative 4 plus 3 gives me a coefficient of negative 1, so that works. Just write A and A. So when I look at this, I'm like, have I factorized the denominator? Step number 1, done and dusted. Step number 2, I need the LCD and I need to write down my restrictions. Write down the LCD and the restrictions. Can someone tell me what will be my lowest common denominator here? The common bracket. Okay, the product of common brackets that have the common bracket with the highest exponent, if it's common. If it's unique, then I also it also becomes available as my LCD with the product. Okay, so a minus 4, for instance, is common for two fractions, so that means a minus 4 can be written down as one of my LCDs. Then a plus 3 is also common, okay, but I would go for the common base that has the highest exponent. But since the exponents are both 1 for a plus 3, they are also 1 for another a plus 3, it means I write that a plus 3 once. So the product of a minus 4 and a plus 3 is my LCD. Okay, that's very important. But in order to avoid having a 0 denominator, a cannot be 4, remember, because 4 minus 4 will give me 0 in this denominator, which I don't want. And a cannot be negative 3, because remember, if I have negative 3 here, plus this 3 will give me another 0 denominator, and I cannot have that. Okay, so like I said, I repeat, step number 1, factorize the denominator if possible, or where possible. Step number 2, you write down the LCD and its accompanying restrictions. Okay, yeah, like I said, a minus 4 and a minus 4 are common for two brackets, so I write down the common bracket with the highest exponent. But seeing as though the exponents are both 1 for each bracket, I write a minus 4 once. Then as a product to a minus 4, I write the other common thing, which is a plus 3. I write it once as well. The highest exponent is 1, so it's a plus 3 once. Then after writing the LCD, then I need to make the denominators be like the LCD. I need to make the denominators to be like LCD. So the LCD is a minus 4 into a plus 3. So in order to make this become a minus 4 into a plus 3, I'm going to take a minus 4 as it is and multiply by a plus 3. But remember, what I do at the bottom, I have to do where? At the top. Okay, because a plus 3 divided by a plus 3, it's like I'm multiplying this fraction by 1. Okay, it's not like making a difference. Plus, do the same thing here. What's missing in the denominator to get a minus 4 into a plus 3? I need to multiply this by a minus 4. What I do at the bottom, I do at the top, in brackets. Minus 21. Now, what do I have to do here to get the LCD? Nothing really. I just need to multiply by 1. Okay, so 1 won't make a difference. If I multiply this by 1, I multiply that by 1, because that is the LCD. Okay, now let's write this entire fraction with the LCD available in the denominator. A minus 4 into a plus 3, this is for all the fractions. Then I'm going to distribute. For distribute numerator and add like term. Distribute numerator, add and subtract like terms. Okay, so I made the denominators to be like the LCD, and I'm sure you saw how I did it. Okay, multiplying top and bottom so that I can make it like the LCD. Now 3 times a, that's 3a. 3 times 3, that's plus 9. 2 times a, that's 2a. Positive 2 times negative 4, negative 8. Negative 21 times 1, negative 21. There we have it, guys. Do you see those distribution of like terms? My denominator has not gone anywhere because this is an expression. 3a plus 2a gives me 5a. 9 minus 8 minus 21. 9 minus 8 is 1. 1 minus 21 is negative 20 over a minus 4 into a plus 3. Now, in the numerator, not a problem, Katlecho, not a problem. My handwriting does tend to be really bad, actually very sucky, so not a problem. I don't take no offense from that. 5a minus 20 in the numerator, Now I can see that I can take out a highest common factor there. When I take out highest common factor of 5, I'm left with a minus 4. Why do I do that factorization at the top? It's because I can see there's a possible cancellation in the denominator. That's why I factorize the top. I wouldn't have factorized the top if there was no possible cancellation in the denominator. So I cancel that a minus 4 and that a minus 4. That leaves me with 5 over a plus 3. Stylish. This is an expression, not an equation. We only do the entire thing of getting rid of the denominator with an equation if we are solving for an unknown variable. This here is a fraction expression. Okay, this is a fraction expression, guys. So since it's a fraction expression, we use the LCD so that we can form the same denominators, but we don't drop the denominator here. We keep it until the end. When you added fractions in grade, I think in grade 7, if you were adding two fractions like this, 1 over 2 plus 1 over 3, remember you found the LCD, you would say it is 6. And then when you found the LCD and it was 6, because this is an expression, this is not an equation, it's an expression. Guys, we are simplifying an expression. That's why we don't drop the denominator. So even if you are adding two fractions, this is an expression, you would try and make your denominators to be the same by multiplying by that number that will give you the LCD. So you have 3 over 6 plus, you multiply this by 2, top and bottom, you get 2 over 6. Does the 6 fall away? No, it doesn't, guys. Okay, the answer is 5 over 6. Okay, so please, expression, there's a difference between an expression and a equation, and I need you to understand that with an expression, if you're asked to simplify an expression, the denominator, the LCD that you find is kept until maybe there's something in the numerator. You see, I factorize, for instance, the numerator here. The cancellation happened here, all right? Yeah, and then the answer was 5 over a plus 3. In an expression, the LCD is utilized so that we can get to a place where we can what? Add the numerators. Why? Because the denominator is the same. Because for fractions, the addition of fractions, we are told that the rule for addition or subtraction of fractions is that you cannot add or subtract fractions unless their denominators are the same. So we use the LCD so that we can form our denominators to be in the same image as our LCD. Okay, I hope that makes sense, and I hope that is crystal clear. Okay. The next set of questions are these ones, solve for x. All right, and I guess if anyone is really interested, I will officially go and sleep after I'm done with everything in this paper, because after this section there is a trigonometry that is there, and then that will basically be the end of the paper. Okay, so right, so I'm just gonna, if you can give me a chance, I'm just gonna write these out first, and then after I've written them down, I will go ahead and answer them, so that if people have any questions, they are more than welcome to jump on and ask their questions. So now we are jumping into solve for x. Okay. All right. I think we can scoot. Okay, there we are, guys. There we are. You can see this beautiful question: solve for x. The first one is saying x plus 3 into x minus 1 is equal to 0. Now, guys, hopefully you guys know this and it's very straightforward. There's nothing much to it. Hopefully we can flow through these very nicely, very quickly. Yeah, guys, for those who are asking me when do my live sessions start, the thing is, it's not very consistent. Sometimes in the weekends when I have time available, I'll hop on and I'll start helping grade 10s and grade 9s, because during the week it's mostly grade 11s and grade 12s and it's them exclusively. So now I just thought today, let me hop on and help out the grade 10s. Okay, and the session, when I'm done with it, I'm going to download that video, going to upload it onto my YouTube channel, so that those who want to go and check out the session again at their own time, at their own pace, they can always go and watch the live session that I did just now. So what you can do, you can go to my bio if you want to know about the YouTube channel. My bio, there's a link of my YouTube channel. You just press there, you go to the link, you go and subscribe there, and then you can check out my playlist for the grade 10, so that you can check out what I've done in the past for past sessions. Like I've taught the basics, full sessions for factorization and so forth. You can always check those out, and that can help as well. So x plus 3 into x minus 1, guys, with solving for x with the quadratic equations, there's a method that suggests that, one, you must write your equation in standard form. Okay, standard form is this form: ax squared plus bx plus c is equal to 0. This is what we call standard form. 2, you must then factorize. Okay, or in other words, factors. Your factors must be equated to 0. Okay, this is what we mean by factors equated to 0. All right. Then 3, you can apply what we refer to as the zero factor law. The zero factor law simply means that you take each respective factor, you equate it to 0. So if there's a 0, though, you only do it if there's a 0. That's why we call it the zero factor law, because it doesn't work if there's another number that is not 0. If there's another number that's not 0, you need to first FOIL, and then you need to transpose the other number and add the like terms, and then you need to get it in standard form. Then factorize, then apply the zero factor law, because this zero factor law, meaning taking this bracket, equating it to 0, taking that bracket, equating to 0, and solving, only applies if there's 0. Only if there's a 0. That's why it's called the zero factor law. And then 4, you write down your roots, or what we call your solutions. Okay, we call them roots when you say x is equal to a or x is equal to b. These are roots, guys. These are roots. We call them roots, or the solutions of your quadratic equation. So if you look at this, x plus 3 into x minus 1 is equal to 0. If you look at this standard form, we've passed a long time ago. We are no longer there. Factors equal to 0, we are there at the factors equal to 0. So what do we need to do next? Apply the zero factor law. Why? Because there's a product of factors, there's 0 on the other side. So all we need to do is say x plus 3 is equal to 0, or x minus 1 is equal to 0. Then we write down our solutions. We just transpose the 3, x is equal to negative 3, or x is equal to 1. Finished. Done. 2 marks in the bag. Not much thought. So that's why it's important to remember this 4-step method. Standard form, factors, zero factor law, then your roots or your solutions. Please, guys, it's just as simple and straightforward like that. That was number 1. Let's look at number 2. 2x squared minus 5x plus 2 is equal to 0. Now if you look at this, this is an advanced trinomial. Okay, now depending on who you are and what method you have learned, okay, you can factorize this trinomial using your method that you have learned at school. Okay, whatever method you have used or you've learned at school, you know, the method that I basically know, which would give me the factors. This 2x squared, to get 2x squared, I have a 2x and a x, just from a trial and error basis, if you will. Then I know I'm going to place a 2 here, because 2 times 2 is 4. But since it's same sign, same as the mother, I know it's minus and minus. And then 2 times 2 times negative, it gives me a negative 4. So the 1 there, if I multiply a negative 1 times a negative 2, it gives me a positive 2. The multiplication of this is negative x, and the multiplication of that is negative 4x. They both give me a negative 5x. So through a trial and error method, I'm able to get the factors for 2x squared minus 5x plus 2 using my factorization method. Maybe some of you have learned a different method, okay, of how to get to a place where you have these factors. Okay, whatever method, at the end you must be able to get to a place where you have these two brackets equated to 0, so that after finding the factors you can then apply the zero factor law and then get the roots. Okay, so this is my way of getting the factors, okay, the product of factors. All right, I know some people, and I'll just write this here for the purpose of factorization. Some people, they use the AC method. Okay, here we have what we know as A, the coefficient of x squared term, and then here we have C, which is basically the constant term. You can multiply these two, and this is basically 2 times negative 2, which gives you negative 4, if you know what I mean. Okay, when you've gotten that negative 4, you need to then find the factors of negative 4. These factors of negative 4, guys, need to simply do the following. These factors of negative 4, they simply need to do this when you add them there. Okay. When you add them there, they must give you negative 5. Okay. They need to give you negative 5. So 2 times negative 4, 2 times negative 2 is negative 4. Yeah. Those factors, when you add them together, they need to give you negative 5. So the factors are negative 4. Yeah. But basically, all in all, guys, just depending on which method you are using, I like using this one. It makes life very easy for me. It's so nice, and easy, and I love it. I love it a lot. I love it too much. I love it too much. So I don't know which method maybe for you find it's nice for you. But whatever method is nice for you, then that's the method I would like for you. So stylish, you got this negative 4 minus x and then remember, you take out the highest common factors because we apply grouping. Minus 4x minus x will give you negative 5x, you see. So if you take out the highest common factor, you get x minus 2. So there's a bit of an issue there. I wonder what's the issue here. Minus 4 minus 1. Okay, there's a bit of an issue there. Yeah, but all in all, this is basically what we are gunning for. I wrote a plus, that's why. I was wondering what happened there. I wrote it incorrect. 2 times 2 is 4. Because this 2 is positive. Sorry, I wrote it down incorrectly. That's why I was confusing myself. Sorry, my mistake, guys. So 2 times 2, the A times C, 2 times 2, that gives you 4. That's positive. Okay, very important. Then you need to find factors. Okay, -4 and -1. Obviously, -4 and -1 will give you a +4. When you add these, they give you -5. So you get -4x and -x. Alright, that you write in the place of -5x. -5x gets replaced by -4, but then you put the x there so that you can actually put them in the place of -5x. Then you apply grouping. 2x is the highest common factor, that leaves you with x minus 2. Okay, and then for this, the first term is negative, so you take out a negative sign, you write x minus 2, which is equal to 0. Remember, whatever you took out there was -1. Okay, then common bracket is x minus 2 into 2x minus 1 is equal to 0. So there are the factors, which are the exact same factors that I had gotten when I basically had factorized using my trial and error method. So I got those factors specifically. It's x minus 2 into 2x minus 1, which is equal to 0. Now I can apply the zero factor law. X is equal to 2. X is equal to half. That's done. That's finished. Okay, x is equal to 2, x is equal to a half. Because you take this 2x minus 1, you also equate it to 0. You solve for x, you get x is equal to half, x is equal to 2. Okay, so great. There's a method, that one. Okay, it's a bit longer, this AC method, but at the end of the day, it helps you to be able to get the factors for that advanced trinomial, so that you can be able to get them and solve for x. Okay, I did do a session at some point with the factorization on my YouTube channel. You can find the session that I did step by step of how to factorize applying this advanced trinomial method. Okay, the AC method, as opposed, of course, to the quicker method, which is the method of using the trial and error. Okay, then exponential equation 2 to the power 3x minus 4. Let's check this out. 2 to the power 3x minus 4 is equal to 64. Okay, all right. Okay, this one, base 2 raised to the power 3x minus 4. So obviously with exponential laws, we know there's this law that says if a to the power x is equal to a to the power y, then x is equal to y. In other words, if you have same bases on either side of the equal sign, you can drop the base and you can equate the exponents. So there has to be same bases on either side. So what we can see here is the prime base 2. It's raised to the power 3x minus 4. So that's fine. That's one base, it's base 2. That means we need to just change 64 so that it has the same base as base 2. So 2 to the power what is 64? You can use your calculator, press 64 is equal to shift fact. You will get this 2 to the power 6. You just write any number that you want to prime factorize. Okay, 64 is equal to shift fact from your calculator. Any other number that you want to prime factorize, you can see that 64 is equal to 2 to the power 6. Now that the bases are the same, what does this rule say? If a to the power x is equal to a to the power y, then the exponents, you can equate them. So we drop the base, we equate the exponents. 3x is equal to 6 plus 4. 3x is equal to 10. 3x, you divide both sides by 3. You get x is equal to 10 over 3. So hopefully you guys understand that. Linear equations from grade 8 and 9. So from this point onwards, there shouldn't be any real problems. You transpose the minus 4, it becomes 10. 6 plus 4 is 10. You then divide both sides by 3. Okay, please, very carefully, guys. When you transpose the minus 4, you get 6 plus 4, which is 10. You divide both sides by the coefficient of x, which is 3. All right, and then 3 divided by 3, you are left with just the x, but 10 over 3 is 10 over 3. We leave it as 10 over 3. Okay. Next beautiful question that you guys had is 27 to the power x minus 2 equal to 81 to the power 2x plus 1. Is it 81 to the power 2x plus 1? Yeah, it is. So 27 to the power x minus 2 is equal to 81 to the power 2x minus 1. So once again, 27 is not a prime base, it is a composite base. By composite, we mean it's numbers that basically have more than 2 factors. Alright, but we want to change it to a prime base. So we take our calculator, we do the same thing. We write 27 is equal to shift fact, then we will get the prime base, which is 3 to the power 3. So we write 3 to the power 3, we write it in brackets, and then we write the x minus 2 outside, please. 81, we do the same thing, that's 3 to the power 4, we write it in brackets, 2x plus 1 as an exponent. We always do that, guys, that whenever we change a prime base, we change it and we write it in brackets. Then now we distribute the 3 to the x and to the negative 2. So that's 3 to the power 3x minus 6, which is equal to 3 to the power 8x plus 2. See that distribution? Okay. Now I'm sure you can see the property can be applied. The bases are the same on either side of the equal sign, so what do? We now drop the base, we equate the exponent, so that leaves us with 3x minus 6 is equal to 8x plus 2. Now we can solve a linear equation, not a problem. So negative 8x plus 3x is equal to 2 plus 6. 8x becomes negative this side, positive 3x stays that way. We have negative 5x is equal to, what's 2 plus 6? It's 8. Then we divide both sides by a negative 5. That leaves us with x is equal to negative 8 over 5. Okay, so I hope we can see that. We transpose. Okay, so from this point, so from here, guys, we take the 3, it's a monomial by a binomial. 3 times x is 3x, 3 times negative 2 is negative 6, 4 times 2x is 8x, 4 times 1 is, oh, did you see that? The error. Woo! Good thing I went back. 4 times 1 is 4. Woo! Guys, what a mistake. Do you see that? Now imagine if I didn't go back, okay, and no one called me out. Everybody is sleeping. Imagine 4 times 2x is 8x, 4 times 1 is 4. Then this is supposed to be 4. Then this was supposed to be 4 plus 6. 4 plus 6, which is supposed to be equal to what? To 10. Which is equal to what? To 10. Which is equal to what? 10 divided by negative 5. Which is equal to what? Negative 2. Did anyone see that error, guys? Or were we all sleeping? Is it too late? Yeah, it's too late, eh? I think people are really sleepy. Must be that. Okay, I nearly sabotaged myself by actually not getting that correct. Yo. Alright. Sure. Younger, did you see that? That was like a car spinning off the wheels. Nearly killed ourselves there. Nah, you didn't see that. So you are sleeping, Younger. Younger is slipping away, and Asanele is slipping away. You just noticed. You guys are funny. Okay, here's an inequality for you guys. Here's an inequality. It's coming up. Let's just grab another piece of paper here. Okay, here's an inequality coming up. Here's an inequality called solve the following inequality. Solve the following inequality. Compound inequality, this one. Okay. So our objective is to isolate the x. 4 plus 2x, the 4 needs to go, so it's a positive 4, so we subtract 4. we subtract the 4 because it needs to go. So we have negative 6 less than 2x less than equal to 2. So far so good. The 2 is multiplied to the x. We divide by 2. But thankfully, the coefficient for x is positive. Because remember, if the coefficient for x was negative, then these inequality signs would have to change immediately as we divide. But since they are positive, there is no change at all. It says negative 6 divided by 2 is equal to negative 3 less than x less than 1. Let's not forget the equal sign. That's fine. Had they said to us, represent your answer in a number line, that would be easy. We would have just said negative 3, written the 1 there. Then here we would write an open dot. Here we'd write a shaded dot. And then we would connect these two dots because the answer lies between negative 3 and 1. 1 is included. All the other numbers in between would basically satisfy the inequality. Negative 3 is not included because it is not supposed to be part of the answer. Okay. If they said write the answer in interval notation, we would have said x is an element of open bracket. Open bracket is for open dot. Okay. I want to write them as notes. Please show them fully. Okay, K baby. Alright, K baby. Let me just show you fully, K baby. So, yeah. So like I was saying, initially here, minus 2 less than 4 plus 2x less than equal to 6. We first obviously want to isolate the x in the middle here. So this 4 needs to go, but it's a positive 4. So we subtract, we use the additive inverse of 4, which is minus 4, to get rid of this 4. But what we do in the middle, we do in the left, we do in the right. So that's why we said minus 4 here, and we said minus 4 there. Okay. Then after doing that, we get in the middle 2x after subtracting 4. We get here negative 6. Then we get the positive 2. Then we look at the coefficient, we look at the middle again. It's 2 is multiplied with x. So what do? We divide by 2 to get rid of this 2. Okay. But what we do in the middle, we do in the left, we do in the right. Okay. But thankfully this was not a negative 2x, because if it was a negative coefficient, the minute we write this down, we would have also written down the signs pointing in this direction, because whenever we divide by a negative, it would change. But we are not dividing here by a negative, we're dividing by a positive, so that's why the signs have stayed the same. Okay. Then we get an answer of negative 3 less than x less than equal to 1. So then, if they had said represent answer in number line, we would have written our answer, because x is between negative 3 and 1. We would have written, really, x is between negative 3, but this less than without an equal means open dot. This less than with an equal means shaded dot. Okay. So that's why the shaded dot, there's a 1. The open dot, there's a negative 3, because there's no equal. Then if they had asked us to write the answer in interval notation, we would have simply said x is an element of open bracket for open dot, open bracket, open dot. So there's always an open bracket for an open dot. Negative 3 to what? To 1. Square bracket for shaded dot. So this would be interval notation. If they had said write your answer in interval notation, this is what we would have written. Okay, further on. Represent answer on a number line. This is what we mean by representing an answer on a number line. Because x is between negative 3 and 1, that's why we have the line being between negative 3 and 1. Less than alone with no equal sign, open dot. Less than or equal to with the equal sign, shaded dot. Okay. Okay, Mataba. Magaba. Asanda Magaba. Did you really get it, Asand? So it didn't get you, you got it. Okay. Then I believe you, Magaba. Alright, here we are. Solve for x and y. This is another episode of Solve for X and Y. Solve the equation simultaneously. Guys, there are two methods to solving an equation simultaneously. You can either use the elimination method or the substitution method. So can I just get, by a show of comment in the comment section, how many people... So if you use the substitution method, just say sub. If you use the elimination method, say Ellie. If you use both, you can just say sub Ellie. If you use the substitution method, just comment in the comment section with sub. If you use elimination method, write down the comment section Ellie. If you use both, just write sub Ellie. Oh, K-Baby. Oh, K-Baby. K-Baby is making me feel so special right now. Really, that's so nice. Thank you. Shelo uses sub and Ellie. Stylish uses sub and Ellie. Oyesa uses Ellie. K-Baby, elimination. Okay, so I'm gonna give you guys then this particular problem. Please do it for me. Do it. I'll give you guys 5 minutes, and then you can do it. After you've done it, please send me share with me your answers in the comment section. I will then do it to just confirm, and then yeah. I personally love the substitution method, Yeah, okay, baby, I guess that's a very kind comment for you to say. Maybe that you understanding me has everything to do with the fact that I'm a stranger to you. Strangers tend to be very, very, very understandable. Solve for x and y. So you need to solve for x and y. This has to be like one of the most longest sessions I've had with the grade 10s. Yo, when did we start? Just after 9? And literally now it's like 11:52. So the people that started off with us are like gone, fast asleep. Toho, Millicent, Daed, Younger, K-Baby, Teddy Bear, IG, Hlelo, Asanda, Nandi, Inoyolo, Mabuto, Mashudu, The Reality, Portia, Soul Apani, _Ino, Nell, Ibu, Nozy, Mr. Dre, The Blood Squad, Kasela, Mpato, Somuta, Bree, Matsebe, Masejo, Short SS, L, in front of the boy. Yeah, you guys are hanging tight. And then I guess I'll get the summary as well to see how many people have been here for the longest time since the inception. Muteo, danko for the follow. Muteo. And the answers coming together, guys. Elimination, substitution. Please let me know in the comment section once you're done. If you used Ellie, just write Ellie and then your answers. If you use sub, you just sub and you write your answers. Yeah. You've got like 30 seconds left. Okay, Tohu just got 2 and 1. Okay, so guys, if we use the substitution method, then we can see that equation 1 is the best choice for actually making either x or y the subject, because you can see our x value is isolated here. It's got a coefficient of 1, so that means it's the best option to making another equation, x is equal to 5 minus 3y. Then the other equation, equation 2, 2x minus 6y plus 2 equal to 0. You can say that's equation 3. Then we are going to sub equation 2 into equation 3. Oh, we call this equation 3 actually, and then we call that equation 2. So we're going to sub equation 3 into equation 2. So we're going to take this guy, take the substance of this, substitute it everywhere in this equation where x is. So 2 into 5 minus 3y minus 6y plus 2 is equal to 0. Yeah. Please guys, that's very important stylish. You take one of the equations, you make either x or y the subject of the equation. So here we can see that this equation, the x here, is already isolated, so it's better to just go ahead and make x the subject of the equation. If we make y the subject, we are going to have a fraction. If we took this equation and made either x or y the subject, we are going to get a fraction for our expression on the right. So that's why I'm saying the first equation is the best bet, because it has a coefficient that is 1. Okay, and that way we avoid having a fraction in our expression. Okay, now we substitute where x is, we substitute 5 minus 3y. So that's been done. We substitute using brackets, please. We use brackets when we substitute, because after we substitute, remember there's a multiplication. Either this is a monomial by a binomial, which means we have to distribute, and it's very important to do that. Then minus 6y plus 2 is equal to 0. Minus 6y gives us minus 12y. 10 plus 2 is 12. If we transpose on the other side, we get negative 12. Then we divide both sides by a negative 12, which gives us y is equal to 1. Okay, so Toho was 100% spot on about the value of y. It is definitely 1. Then we go ahead and we look at that equation where we had made x the subject. We go there, we substitute x is equal to 1 into equation 3. So x is equal to 5 minus, sorry, not to substitute x is equal to 1, substitute y is equal to 1 into the equation. Remember, we had gotten the value of y. So we go and substitute y is equal to 1 into this equation that we had set up. So x is equal to 5 minus 3. In the place of y, we substitute 1. What's 5 minus 3? It is 2. So x is equal to 2. So x is equal to 2 and y is equal to 1. We could write this as a point. like we know that this is a point of intersection. Okay, this is for grade 10. Okay, baby, what grade are you in? So 2 and 1, guys. 2 and 1. Okay, so very important. I repeat again that when we are using the substitution method, we take one of the two equations, preferably the one that has the coefficient of 1 or -1. We make that the subject of the formula. So in this case, we made equation 1 x, we made x the subject of the formula. So we took the 3y over, it becomes -3y, took the -5 over, it becomes +5. Then we made that equation 3. Then we took equation 3, we substituted it into the other equation. We can't substitute the equation into the same equation, substitute the equation into the other equation. So where x is, we substitute 5 minus 3y. That's what this means. Where the subject is, we substitute the right. Where the subject is, we substitute the right. So that's why we substituted 5 minus 3y where x is, which was 2, into place of x, we substitute 5 minus 3y. Does that make sense? Yeah. And then minus 6y, followed by minus 6y, there it is, followed by plus 2, there it is, equal to what? Equal to 0. Then we distribute. 2 times 5 is 10, 2 times -3y is -6y, then followed by -6y, followed by plus 2 is equal to 0. We add like terms, minus 6y is minus 12y. Then we divide both sides by the coefficient of -12y, which is -12. Remember, this 10 plus 2 is 12 as well. Take it over, it becomes -12. So we divide it by this -12, but what we do on the right, we do on the left and right. Then we get an answer of y is equal to +1. When we get that answer of y is equal to +1, we go and substitute it back where we had made x the subject. Go and substitute 1 in the place of y where we had made x the subject. 5 minus 3y in the place of y, substitute 1. 3 times 1 is 3. 5 minus 3 is 2. So x is equal to 2 and y is equal to 1. And that basically dusted 2 and 1. Okay. Right, so that basically concludes that algebra part of our question paper. And then to finish off, I'm just gonna finish off, guys, seeing as though like this is nearly the paper done and finished. Let's finish off, and this is the last part. Okay, the trigonometry for the grade 10. The last part, trigonometry for grade 10. Okay, let me just write down the question. So I'm sure you guys can see the questions. Okay, I just want to take down the question so that you can then use it to answer. Okay, and I'm guessing this question paper just did some introductory parts, not really full depth. Grade 10. But that's okay. At least it will give us something to work on, and then maybe at another session we'll in the future we'll look at, but this will suffice. Okay, this will suffice for the purpose of what we want to do. So trigonometry, guys, remember the word trigonometry actually means the trig part of it means triangles, right? But in grade 10s, we specifically look at right angle triangles. We look at the rats. The rats. It's all about the rats. Right angled triangles. We look at that in grade 10. So a right angled triangle, as it says in the problem, so the trigon part means triangles. Metry means measurement. Okay, so we are looking at the measurement of triangles, specifically right angle triangles. And what are we measuring, guys? We are measuring the sides and we are measuring the angles. Okay, so it's just angles and sides of right angled triangles. Okay, what's humorous? The measurement. So metry means measurement. Trigon, okay, is basically triangles. Okay, so here we are. Yes, the rats, the right angle triangles. It's all about the rats, guys. Yes. Amaroto, as they would say. Okay, here we are. A right angle triangle. A right angle triangle has sides PQS and angle theta is shown below. So there we have it. Sides P, Q, and S, and we have angle theta here. So they say write down the values of PQS for tan theta. Okay, so hopefully we all know SOHCAHTOA. Really? We all know SOHCAHTOA, right? Sine theta is equal to opposite, that's the O over hypotenuse. Most obviously, this is the side opposite the angle that you're talking about. Hypotenuse is always opposite the right angle triangle, right angled. Cos is adjacent over hypotenuse. The word adjacent means next to, all right? Then hypotenuse is always the side opposite the 90-degree angle. Tan is opposite over adjacent. Tan, toa, opposite over adjacent. Cos, ka, adjacent over hypotenuse. Sine, so, opposite over hypotenuse. Okay, so we are looking at this triangle. This is the angle theta, and we are asked to find tan of angle theta. Okay, and these trig ratios only apply to right angle triangles. So let's look tan of theta. Okay, so theta is here. What's opposite that angle? It is S. So that means tan is S, because S is the opposite side. Okay, toa, remember toa, opposite over adjacent. So the adjacent side is the side that is next to the angle you are talking about. So the side next to is Q. It is not P, because remember, opposite the 90-degree angle, we have the hypotenuse. The hypotenuse is always opposite the 90-degree angle. Since we are looking at theta in terms of the angle, in reference to the angle we are talking about, the opposite side is opposite theta. The side next to theta is Q. That is the adjacent side in terms of this angle. If, let's say, there was another angle, and let's say the angle was beta, and we were asked tan of angle beta, this now, in terms of angle beta, this here Q is the opposite side, and S would be our adjacent side if we are looking at this angle. So you must check the angle that they are talking about, because the adjacent side and the opposite side will be in accordance to the given or the referred angle. Okay, so that's why we're saying tan of theta is opposite side S over adjacent side, which is Q. So S over Q, S over Q, S over Q. I hope it makes sense, guys. I hope you understand now. Opposite side over adjacent side. That's tan. Okay, any questions from anyone? Yanga panga, stylish humor. Samuel, any questions? You have questions? Is that a yes for questions? I'm listening. I'm listening if you have questions. Okay, Stylish says all good there. All good. Oh, no questions. Okay. Negative sine theta. Okay, so they have said negative sine theta. That means negative. Yes, that is the final answer, S over Q, because they want us to write down the values of PQS in terms of tan theta. I mean, they want us to basically write tan theta in terms of PQ and S. So tan theta is by definition opposite over adjacent. So the opposite side in reference to this angle, opposite side is S. Adjacent side is Q, because the adjacent side in reference to this angle theta is the side next to the angle we are talking about. Okay. And the opposite side is always the side opposite the angle you are talking about. Okay, so that's why we say opposite S over adjacent Q. Let's look at this one, negative sine theta. So since they have a negative, we must write down negative. Remember, the definition of sine is opposite over hypotenuse. In other words, it's opposite S over P. Okay, meaning opposite side over hypotenuse side. That is sine of theta. Negative sine of theta is negative S over P. Okay, all right, please. Okay, so like I said, that's why it's important to know these mnemonics. So sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Adjacent over hypotenuse. Toa or tan. Tan is opposite over adjacent. Oa, opposite over adjacent. Okay. So like I said, if you're looking at tan theta, you go look at the angle theta. What is the definition of tan? Tan is opposite. What opposite? The side opposite the angle you are talking about is S. Over adjacent. What is adjacent? Adjacent means the side next to the angle. All right. Why are we saying the side next to the angle is Q and not P? It's because P is always the hypotenuse. Why? Because the hypotenuse is always opposite the 90-degree angle. And the side that is opposite the 90-degree angle is P in this case. So it is the hypotenuse. It never changes. The adjacent side then would have to be Q. So if we look at the definition of tan, tan is opposite, which is S, over adjacent, which is Q. Sine of theta, in other words, negative sine of theta. The negative sine of theta will be negative. Now, what is the definition of sine? Definition of sine is opposite over hypotenuse. What is the opposite side of this angle theta? It is S. There it is, S. Over P. P, the hypotenuse side. Because remember, the hypotenuse is opposite the 90-degree angle. So it is negative S over P. Opposite over hypotenuse. No, the thing is, that's what they said in the question. Okay, they said we must write down the ratio of negative sine theta in terms of P, Q, and R. So that's why in our answer we wrote negative S over P. If they had said positive sine theta, then we would have positive S over P. So we write our answer in accordance to the statement that we were given. Then let's look at the last one. 3 sec squared theta. Okay, now we also have what we refer to as our reciprocals. Okay, yeah, 1 over sine theta is actually equal to cos sec theta. 1 over tan theta is equal to cot theta. And then last but not least, 1 over sec theta is equal to cos theta. So in other words, the reverse can also be said that sec theta is 1 over cos, tan theta, cot theta is 1 over tan, and then cosec theta is 1 over sine. Yes, so these are inverse functions, guys. Inverse. Okay, yeah, inverse. The inverse trig ratios. Okay, inverse trig ratios. The inverse trig ratios. Okay, so if we look at sec squared theta, all right, yeah, sec squared theta. If cos theta is the inverse, that means if cos theta is adjacent over hypotenuse, then sec is hypotenuse over adjacent. Okay, yeah, because cos and sec are inverse trig ratios. Okay, so if cos is adjacent over hypotenuse, then rest assured that sec is hypotenuse over adjacent. So I come here, I need to find what sec squared theta is. So in other words, if I go to theta, what is sec? Sec is hypotenuse over adjacent. In other words, it's P over Q. Like I said, hypotenuse over adjacent. Sec is simply P over Q. But since there's a square there, I put a square on the outside. Then I apply my exponential knowledge. I know the answer is P squared over Q squared, because when there's division of bases and there's an exponent externally, we simply apply the exponent to the numerator and the denominator by multiplying the exponent for each respective base. Okay, and there it is. There it is. Because we know that cos is the inverse, okay, of sec. Very important. Those are inverse trig ratios. Okay. Okay, then last but not least, the last question that they have here, it says if it is given that P is equal to 12 and theta is equal to 35, calculate the numerical value of Q. Okay, so let's do this. We are told it is given that what? P, which is actually here, is equal to 12. Q, we don't know, theta is equal to 35. And then they are saying calculate the numerical value of Q. Okay, so we have the angle, we know that this is 90. We have this given to us, we want this. So what is this and that in relation to this angle? What is Q and what is P? What is Q? We call Q what side in relation to this angle, and we call P what side in relation to this angle. Q is called the what side? Opposite, adjacent, or hypotenuse? Yes, thank you so much, Stylish. It is adjacent. And then P is called the opposite or adjacent or hypotenuse. Okay, it is the hypotenuse. And I'm guessing Samuel has got it down. It says adjacent over hypotenuse. What trig ratio gives me adjacent over hypotenuse? Because that's what I want to find. I need to use that trig ratio to find the missing side of Q. So yes, Q is the adjacent. P is obviously the hypotenuse. What trig ratio is adjacent over hypotenuse? Thank you, Samuel. It's cos. So I say cos 35 degrees is equal to Q over 12. You guys are spot on. See? Cos 35 degrees is equal to Q over 12. Then I need to make Q the subject of the formula. The 12 is in the denominator divided. So what do? I multiply both sides by 12. What does that do? It cancels out the 12 in the denominator. Q is equal to 12 times cos 35 degrees. Now you use your calculator, get the value of Q, and you tell me what it is. I'll wait. I want the answer. 12 times cos 35 is equal to. I want the answer, guys. Twelve times cos 35 is equal to. Thank you, Samuel. 9,6. So it's obviously 9,6 units. Okay. Okay, and that was that. Okay, guys, that was the full complete paper we just answered. This is the paper that I uploaded onto the TikTok page, okay, for the grade 10s, because I uploaded a past paper, okay, that was written for a control test in Term 1, and it actually is on my TikTok page. I had not posted any memo, so I decided to actually hop on today and do it. It's just as a way as well of doing some revision for the grade 10s, because I haven't done a session with you guys in quite a long time. So thank you so much for joining in, guys. That's as much as I have for you today. I have to go and sleep now. So what I'll do is I will save the video. I will actually upload it onto my YouTube channel as soon as I can, and you can revisit and rewatch it at whatever time you have available, maybe during the course of tomorrow if there's something that you missed, or if there's anything that you may have sort of like not got or did not understand when I was actually doing it with you guys. Asanda, thank you so much. Good night, and thank you too as well. Thank you for joining in, and thank you for being so patient. You guys have really been great sports. Yeah, you must take care of yourselves and be good. Need calculus. Yeah, I think there's a lot of things that people need when they join these live sessions. But yeah, this was for the grade 10 specifically. I came with that intention. I'll see the grade 12s and the grade 11s in the week. But I just needed to come on here and just help out the grade 12s, grade 10s for a little while. It's been a long time. It's been a long time coming. So I hope the revision was helpful, and that you guys in the coming weeks, as you prep yourselves even more to write, that you'll prepare yourselves accordingly. I will try and upload more past papers for Term 1 control tests from other provinces as soon as I am able to get a hold of them, and any other material that may be helpful I'll upload. Okay, but please take care, and thank you again. Have a good night, and yeah, maths is a game. Continue playing it, and you'll pass with distinctions, and happiness shall definitely be your lot in life. Thank you. Thanks, Tor. You're welcome, man. You're welcome. I'm glad you guys appreciate the help. I'm glad.